Let me show you what content we are going to cover. So here is the updated content for the CCIE Enterprise Infrastructure Lab exam, within the scope of which we have the topics of Cisco SDA, Software Defined Access. So this is the version 1.1, which will start from 20th September. So this is the content that we are going to cover. And in this content, we have this topic called Software Defined Networking. In the Software Defined Networking, we have the topics of Software Defined Access, SDA, and the Software Defined WAN. So SD-WAN is covered in dedicated separate training, ENSDWI, which is also a certification exam as per Cisco. But for the SD-Access, there is no dedicated certification exam as of now. So the content that we are going to cover in Cisco SD-Access is purely going to be focused on the part that we have in CCIE Enterprise Infrastructure Lab exam. So what topics are we going to cover in this Cisco SD-Access? First of all, we will talk about the underlay network, the overlay network. Cisco SDA basically is a technology to manage our campus local area network, campus LAN devices with the help of some controller. We can manage all these campus LAN switches and devices basically with the help of a centralized controller referred to as the DNA center. So DNA center is basically a hardware controller that Cisco sells. This controller acts as a centralized point from where we can control our campus local area network, both wired and wireless. So DNA center comes as a hardware appliance that you need to purchase and install in your environment, in your LAN environment. And then DNA center will be able to configure, manage, provision, and all those things about the wired and wireless devices. So we can manage wired and wireless infrastructure from the Cisco DNA Center hardware appliance. So we have to build a topology based on the SDA so that the DNA Center is able to reach to all those devices, and then it can manage all those devices from one centralized point. So this concept of underlay and the same. How are we going to create the Cisco SDA fabric? What is underlay? What is how the underlying infrastructure, like how the switches must be connected to each other, how it should be connected to the external network and all. So basically, from the design point of view, how the underlay network has to be there, how the underlay network can be built, how can we build the underlay network, and then how can we build the overlay network on the top of the underlay network. Overlay basically is a logical network built on the top of the underlay network. What protocols, what methods are used in the underlay network, what methods are used in the overlay network. We are going to talk all about that. So once we have our underlay network completely up and running, then the DNA center is able to build the overlay network on the top of that underlay network. It's more like such as, for example, in case of DMVPN, such as we have DMVPN where we have our underlying connectivity between the hub router and the branch router with the help of a service provider, ISP, and then we build logical tunnels on the top of that underlying infrastructure to route our traffic from one point to other point. Similar concept. Here we are going to build first of all our underlying infrastructure. Then on the top of that underlying infrastructure, we are going to build some overlay network, which will be managed by both of the things can be managed by the Cisco DNA Center appliance. So we will see how to build the underlay infrastructure, how to build the overlay network, what protocols are going to be used as the control plane, data plane, policy plane, what is this concept of layer 2 flooding, multicasting. We are going to talk all about these like overlay and underlay concept, how to build the underlay network manually with the help of LAN automation, PNP, how can we discover the devices, add the devices into inventory, what types of devices we have. We are going to talk all about these like hardware infrastructure to build our underlay network, and how can we build variety of tunnels on the top of that underlying infrastructure, which is going to be part of the overlay network. Then once we have our underlay and overlay ready, then how can we build our campus fabric on a single site, on multi-site, and what is this concept of fabric in a box? So fabric basically means like SDA fabric, which is more like a logical overlay network built in one site, built in multiple sites. If multiple sites We have built the fabric in multiple sites, then how we are going to connect those multiple sites and all. So we'll talk about like connectivity, transit connectivity between the site number 1 and site number 2. So how can we build the SDA fabric? We can build the SDA fabric in one site. We can build the SDA fabric in multiple sites. And how are we going to connect these multiple sites together? And what is this feature of fabric in a box? So we'll talk about like fabric design in the third point. We will see how can we build software defined campus area network in one site, in multi-site, how are we going to connect it, and how can we have this feature referred to as fabric in a box feature, right? So this is we are going to cover here. Then how can we deploy the end users? Let's say, for example, this is a switch, and from here an end user has to be connected. So how the host onboarding can be done, how the authentication will be done, how the port configuration is done, what is this border router, multi-site border router, border priority, how can we add the devices to the fabric. Basically, the end device onboarding point of view, all the things we are going to cover in this particular chapter. How to onboard the end devices is going to be covered in this chapter of host onboarding. All the concepts of end user onboarding, host onboarding, and related concepts such as authentication templates and everything will be covered in this fabric deployment option. Then border handoff, like if you have to connect your SDA network to outside network, outside legacy network, outside internet, for example, cloud and everything. So how are we going to connect our SDA infrastructure? How can we connect our SDA campus area network to outside networks such as internet, outside networks such as, for example, other branches, outside the network such as cloud? So what is this concept of border handoff? Border handoff basically allows you to connect your SDA fabric to outside the network. So that we are going to cover. SDA, how can we have like this connectivity from our SDA to outside network? What type of connectivity we can have? We can have like SDA as a transit. We can have SD-WAN as a transit. We can have IP as a transit. So we are going to talk about different types of connectivity options when we need to connect like one site with other site or one site with the external network. What is this peer device or referred to as the fusion router? What is layer 2 border handoff? Basically, we are going to talk about the connectivity of our SDA network to the outside network. Then segmentation, using like concept of VN, virtual network, also referred to as VRF. So how can we segment like multiple departments, such as, for example, our corporate user, guest user, IoT devices? How can we do the segmentation between these different types of devices using this concept of VN or VRF? And within the corporate user, let's say, for example, we have a HR department, finance department, admin department. How can we achieve the segmentation within the virtual network using tags, scalable group tags and scalable group ACLs? This is what we refer to as micro segmentation, and this is what we refer to as the macro segmentation. Macro segmentation basically means like where we are grouping our users based on, let's say, for example, their use cases, such as our corporate user, our guest user, our IoT users. To perform the macro segmentation, we use the concept of VN, also referred to as the VRF. And to perform the micro segmentation within the corporate group, we have a HR department, finance department, and the admin department. So we can create three like groups referred to as the scalable groups, and we can define the segmentation between them using scalable group tags and scalable group ACLs. So macro segmentation, we are going to talk about here as well. Apart from that, we will also talk about assurance. We will also talk about wireless. Although our content does not allow for those topics to be covered, but we will talk about like the assurance feature, and we will talk about wireless. We will see how the wireless LAN controller can be onboarded in our SDA deployment. How can we manage, for example, like variety of access points from our DNA center, how the wireless users are connected, what information we can receive and all that. So assurance and wireless topics are also going to be covered at the very end. A lot of topics here are not mentioned, such as, for example, templates, LAN automation. A few topics that are not mentioned here, we are also going to cover them as a part of our training. So these are the main topics that we will focus on, because these are like official topics from the Cisco itself that you should know in our SDA curriculum. These topics are expected in the exam. Like these topics, they might ask in the exam, like underlay, overlay, and all those things. So we will focus more on these topics, and then other topics, additional topics that we have, such as wireless and everything, that we are going to talk about as well.
We cannot integrate that ICE in that.
We can do that. So right here.
Okay.
So when we talk about the overlay network, then we will talk about the components, like what things DNS Center uses at the control plane, data plane, and the policy plane. Here we are going to use the ICE. So we will talk about the ICE integration and everything. So this is the official content that we will be covering. Apart from this official content, we will have other topics such as multicast, such as assurance, such as, for example, we will also talk about the wireless in our SDA deployment. Right. So this is the content, this is the topic that we are going to cover as a part of Cisco SDA training. Right. And how are you going to cover all these topics? You can cover all these topics from the official book. I would not say that it is an official certification guide, because there is no official certification for the SDA. So this is one official book that they have. This is one like for Cisco SD-Access, for Cisco Software Defined Access. They have one official book. This book actually came way before the SD-WAN book. So Cisco SD-Access, actually, this is the official book that you will get, and you can cover things from here itself. This book is not like, I would not say like it's like it covers all these necessary topics, but it's just too much theory. Like, for example, in starting few chapters, like in starting 3 chapters, they have just defined 4 chapters, I would say. In starting 4 chapters, they have just defined like what is SDA, why we need SDA, what is DNS Center, why we created the DNS Center. Those things are covered in starting 4 chapters. Basically, these things could have been covered like in 1 or 2 chapters maximum. So I would not say that it's a very great book, but like this is the only option that we have at the moment. So you will cover all these things from this official official guide. Actually, it is not a certification guide. This is the official book from where you are going to cover all those things. There are approximately, I think, 300 pages that you can go through, and you will get all the things that you need to know from your production point of view in your SDA deployment. It covers basically everything that DNS Center has to offer from the SDA point of view. This book is specifically for the SDA. Just to give you an idea, DNS Center is a hardware appliance that you need to purchase and install in your production environment. Nowadays, it also comes as a software appliance that you can run on the clouds such as AWS, or you can run it in a virtualized environment such as ESXi. It will require a lot of resources, but can be done. So DNS Center is basically a appliance that you need to purchase and install in your network, either as a hardware appliance or as a software appliance. Then you will need devices such as switches, routers, WLC, access points, ICE. You need all these devices so that like a DNS Center will be able to manage. Like, you need all these devices which are compatible with the DNS Center. Like, you cannot have just a regular switch. The switch must be compatible with the DNS Center. You cannot have a regular router. It must be compatible with the DNS Center, WLC, AP, ICE version. Based on what release of the DNS Center you have to buy the compatible devices and build your campus network based on this. So you purchase the devices, you build your infrastructure, then your DNS Center will be able to manage this infrastructure from a centralized point. Within the scope of the DNS Center, we have one thing called SD-Access. SD-Access is one part of the DNS Center. In SD-Access, we can create our campus fabric, we can manage our campus fabric, we can define different roles and everything, but that is not it. DNS Center is just one thing that your SD-Access is just one thing that the DNS Center can offer. DNS Center can offer other things as well. SD-Access is one of those things that DNS Center can offer. DNS Center can also be integrated, for example, with the with some other third-party appliances. It can also be integrated with other Cisco appliances as well. So SDA is just a part of the DNS Center. We are not going to cover like everything about the DNS Center. Our content will specifically focus on the SDA training. Since it is Cisco SDA training, we will focus more on the topics that are covered in here. that are mentioned in actually here. So all these topics that are mentioned in here, which specifically focus on building the campus network and managing that campus network from a centralized point, such as DNS Center, we are going to focus more on these topics actually. SDA is just one part, one thing that the DNS Center offers. Apart from the SD-Access, DNS Center offers a lot of other things as well, such as integration of the wireless devices, ICE, other other appliances such as vManage, StealthWatch, Umbrella. Different options are there in our DNS Center. We are specifically going to focus on the SDA. So it's not like in our training we will go in and out of the DNS Center. No, we will just cover the SDA topics in more detail, and then rest of the things that the DNS Center has to offer, we will just talk in brief in a summary. But we are not going to go through like each and every options in our DNS Center one by one.
Can you integrate AD as well?
AD integration is also possible, right? So I'm just clear. Let me show you like what things we are going to cover, so that it gives you better clarity about the content, and then you can decide like, okay, is this beneficial for your production environment or not. So this is what we are going to cover in brief. These are the topics that we are going to cover in brief. First thing, we will talk about what are the challenges in the modern day network. We will see what are the challenges in our modern day networks are. Then we will talk about like how SDA, how Cisco software defined access, SDA solution can overcome these campus area network challenges. Then we will talk about this is like starting 3 chapters of your book, like starting 2-3 chapters of your book. So we'll talk about the challenges in a traditional network. Then we will talk about how software defined networking has solved those challenges. Then we will focus specifically on the SDA solution for the campus area network, how the SDA has actually solved the challenges in a campus area network. Then we will talk about the SDA architecture. How can we build our SDA network? In the SDA architecture, we have 4 layers. One is the physical layer, one is the network layer, one is the controller layer, and one is the management layer. We will talk about like from the SDA architecture point of view, how can we build our SDA network, starting from the physical layer, where we will talk about the devices and the roles that we can set on the devices. Roles means like edge node, control plane node, border node. We'll talk all about that. Then what is this fabric in a box feature? We will talk about that. Basically, we will talk about the physical layer. How can we build our physical infrastructure? Then we will talk about the network layer. How can we build our underlay network manually, automatically? We'll talk about that. Then we'll talk about the overlay network. In overlay, we have protocols such as Lisp. We have protocols such as VXLAN. We also have this thing called policy plane, which is ICE. So we will talk about ICE integration and everything under the network layer. Then we will talk about the controller layer. In the controller layer, we will talk about the DNS Center installation. How can we install the DNS Center as a fresh appliance? What basic configurations are needed in there? How can we set the users and everything? We are not going to install the DNS Center from the scratch. It takes like a lot of time, 8 to 10 hours it takes. So we are not going to install the DNS Center like completely fresh, but we will like begin like from the scratch, like we will configure the DNS Center from the scratch. I will show you from the documentation how can we purchase and install a DNS Center in our campus network. How can we do variety of configuration, initial configuration on there, and how can you make your DNS Center reachable to the rest of the network. This thing we will talk about from the document. It is just not possible to show you like installation configurations in the premises because it takes like a lot of time. So first time setup, we will talk about that. Then we will talk about how can we define variety of roles, what initial settings you should change on your DNS Center hardware appliance. And then we will talk about things such as, for example, ICE, Identity Services Engine. We'll talk a little bit about ICE, what is ICE, what the functions of the ICE are, how the ICE is beneficial in your network and all that. Then we will talk about how to, this is not an ICE training, so we'll again not go through in and out of the ICE. ICE training is covered in a security. So if you want to go like for ICE, if you want to know everything about ICE, you should opt for the ICE training. As a part of our content, we will just talk about the fundamental of ICE and then what functions ICE has to offer and what out of those, like what functions are used in our SDA deployment. So basic fundamentals of the ICE, then how can we integrate ICE with our DNS Center. So this topic is going to be covered in, all these topics are going to be covered in the controller layer. Then the management layer basically like how can we manage the devices from the, how can we manage the DNS center actually? Are we going to use the graphical user interface or are we going to use the APIs? So how are we going to manage our DNS center hardware appliance? So what are different options that we have in our DNS center? What are different workflows that we have? We will talk all about that in our last layer, which is what we call as the management layer. So from the architectural point of view, physical layer, network layer, then we have controller layer, and then we have the management layer. These 4 layers are there that we are going to talk about in detail as a part of our SDA training. By the end of these 4 topics, we will have our underlying infrastructure ready. We will already have set the roles and everything. These topics such as, for example, device discovery, assigning the devices to the sites, provisioning and everything will be done by then as well, right? So from the lab point of view, like how can we discover the devices, how can we assign the devices to the site, how can we use LAN automation feature to build the underlay network in an automated fashion, how can we create the fabric site, how can we configure the roles onto the device, what is this layer 3 handoff, host onboarding. These all are practicals. Fusion router, port assignment, how the DHCP works in a SDA, so how the end users are going to get the IP assignment, VN, a virtual network like VN, SGT assignment, how can we configure policy, what are variety of verification commands, like this all is lab. IP transit, SDA transit, SD-WAN transit, LAN automation, authentication template, this all is lab. Tools, multicast, layer 2 flooding, layer 2 border, everything. This is all lab. Layer 2 intersite, DHCP process theory, inter-subnet communication theory, templates lab. How can we configure variety of templates in SDA, PNP, WLC. This is wireless part. At the end, we have the wireless in one day, and then at the very end, we will talk about the assurance tools in our SDA, which is monitoring tools. So from here all the way to the end, it is more like going to be lab, and from like starting a few classes, we will have the theory. So this is the specific content. This is the content that we are going to cover specifically in our training. Like this is approximately 20 days content that we are going to talk about in our Cisco SDA training. So for example, wireless and everything is not part of our content, but we are going to cover it in our content like anyway. WLC, AP, like and a few other topics which are not part of our content. We will talk about that in our training because this is there in the book. When you go through this book, in this book, you will find the chapters that actually focus on these topics. So if you go here, you will find these topics such as, for example, we have like today's network, then introduction to SDA, then introduction to the DNS center. So first they have discussed like what is SDA, then they have talked about like what is the DNS center. Then they have talked about the SDA fundamentals. So this is also SDA, this is also the SDA. They have talked about the SDA here, they have talked about the SDA here. So starting like 4 chapters is a mix of like why we need SD-WAN, why we need software-defined networking, and how the DNS center has solved variety of challenges in our modern day network, and what is the SDA solution within the scope of the DNS center. So 4 chapters, so starting 4 chapters completely focus on the basic fundamentals of the SDA and the DNS center. Then advanced topics such as, for example, ICE integration, how the SDA operates, and then advanced DNS center concepts, advanced SDA concepts. These are some like advanced topics that we have to cover as a part of our content. And at the very end, we will have the assurance options. In detail, if you go through the content, we will see like, a modern day network, how can we design the modern day network, what are the challenges that we have in the modern day network. Then we have like, what is DNS center, how the SD-Access solves those challenges that we have in our modern day network. So 4 chapters are going to focus on the fundamentals of the SDA and how the SDA is going to solve those challenges in our infrastructure. Right. And then we will talk about then advanced topics such as, for example, ICE. Then we have like, they have talked about like ICE deployment and those things. So you can go through that. We'll talk a little bit about the ICE as a part of our content, and then we will directly see how can we integrate ICE Identity Services Engine with our DNA Center. Then advanced Cisco SD, how the SD operates and what basic verification commands we can use from the troubleshooting point of view. DHCP, wired host onboarding, intra-subnet, inter-subnet traffic, how the communication happens, how the auth policies are configured and everything. These are some like topics how the SD operates. These are the topics under how the SD operates. Then we have like how the advanced Cisco SDA topics such as like extended nodes, policy extended node, how can we configure the connectivity from the SDA to outside the SDA network, all those things, multicasting, like, what different options of multicasting is there, native multicast, head-end replication, layer 2 flooding, layer 2 border, transit. These are some advanced topics that we have under the scope of this advanced Cisco SDA topics. And then the DNA, advanced DNA center topics like hardware appliance. What is the DNA center hardware appliance? How many number of DNA centers we need to purchase and install? How the connectivity is going to be there? What is HA in DNA center? What are the options we get in the DNA center, such as how can we manage software images? How can we use the templates? Although it is not part of our official content, but since they have covered it in the book, we will talk about these contents as well. So whatever is mentioned in this book, we will cover one way or another. Whatever things are possible to cover in lab, we will cover it in lab. Whatever things are not possible to cover in lab, we will cover it as theory. Right, so this is what we are going to focus on. This is one book that you can refer, and if you just want to, like, keep the things short, if you just want to get the overview and everything, so you can also go through this book. There's also like this book as well. This book actually is very like simple. It is like they have cut out all the like more like unnecessary things. So this is like one more book that we have here, which not has like a lot of chapters. It is like some basic things. So initially they have talked about like what are the challenges in a modern day network, and then they directly went to the SDA and then how to create. They have not talked about unnecessarily like in 4 or 5 chapters what is SDA and all. So this is only 172 pages. This is also one book that you can refer. This is comparatively better than the previous one. They have talked about all the things that are necessary from our campus software defined networking point of view. So this is pretty good book as well. This one you can also refer. If you want to get in very details, then go through this book. If you want to just get the things in summary, you can refer to this book as well. Right. So this is a good book as well. So these two options are there. From where you can cover the things, cover the content in very much detail. If we cover this and this, it will cover everything that they have asked in our official Cisco SDA content. There is no official certification, so we cannot say that this is official certification guide. This is just a book that they have written from the SDA knowledge point of view. Since SDA is a new technology, not a lot of people are aware of it. So this book actually came long before the software defined WAN, SD-WAN. So you can refer to this book for the detailed discussion, or you can refer to this book for the summarized discussion as well. And this is the content that we are going to cover. This is everything. Approximately 20 classes we will require. 1 month maximum we will require to cover this content. We will have the classes from Monday to Friday. So maximum like 1 month will be sufficient. By the end of like next month, we will complete this content. We will have the classes on the Fridays as well. Right, so this is going to be a mix of theory and lab. So any doubts, anyone so far? Let me know. Any questions, anyone? What things you should know before we start our SDA training? What things you should know beforehand? So you should have understanding of switching. Basic, and I would not say like complete understanding, but if you should have the basic understanding of switching, such as, for example, from the design point of view, what is this 2-tier design? What is this 3-tier design? Right? Access, distribution, core, 2-tier design, where the end users are connected. What is VLAN? what is STP, VTP, like basic switching fundamentals you should be aware of. Basic routing fundamentals you should be aware of as well, specifically the protocol BGP. Border Gateway Protocol, you should know what is BGP, what is, for example, like AS number, what is eBGP, what is I-BGP, how the BGP neighborship is formed and everything. You should be aware of the BGP fundamentals as well.
There is an underlay there where they are using ISS.
We'll talk about that. Just wait. So from the routing point of view, what things you should be aware of? You should be aware of protocols such as BGP. BGP is a protocol that we will be using in the layer 3 handoff. So up to this point, you will have some time to cover some basics of BGP if you don't know about the BGP. So in BGP, you should know what is this I-BGP, what is this eBGP, how the I-BGP neighborship is there, how the eBGP neighborship is there, what is AS number, basically like redistribution, basic things about the BGP protocol you should be aware of. No, you should also be aware of like protocols such as, for example, some IGP protocol, such as, for example, EIGRP, such as OSPF. Basically, you should have the routing fundamental knowledge as well. Fundamental knowledge of routing you should have. We will be using both EIGRP and OSPF as a part of our underlay connectivity. So we can use EIGRP or we can use OSPF to make the underlay connectivity. So here, right here, underlay network. So when we manually build the underlay network, we can use any IGP protocol that we want, such as EIGRP or OSPF. So you should have the understanding of the IGP protocol such as EIGRP and OSPF. And when DNS Center automatically builds the underlying network, then it uses a protocol like ISIS. So we don't need to know a lot about the ISIS. This ISIS protocol, like a little bit, we will talk about when we talk about the automated underlay. So when we use the DNS Center to build the underlay infrastructure in automated fashion, there we will talk about this ISIS protocol in brief theory format. So even if you don't know the ISIS protocol, it's okay, because a few things about the ISIS we are going to cover in our content. This is like from the routing point of view. You should know like what is routing, how to configure the routing protocols, EGP, IGP, those things you should be aware of. Basic routing knowledge will be required in our SDA content. Then from the security point of view, what things you should be aware of? You should be aware of basic fundamentals of ICE. We will, however, talk about that, but we are not going to go in complete detail of like ICE, like such as, for example, how to deploy the ICE, what is ICE, like how can we, create like multi-node ICE deployment, single node ICE deployment. We'll not talk about in very detail of those things because that is specifically covered in the ICE training. So you should have like basic fundamental knowledge of the ICE, what things ICE can offer, what is like authentication, what is authorization, what is like policy in ICE. So basic things you should know about the ICE as well. Not a lot of things, again, just basic fundamentals of the ICE will be required as well. Like when we say authentication, you should know what is authentication. We will talk about that, however, but you should, if you have some basic understanding beforehand, then it will be much more easier to you to understand like all these topics. So basic like security concept you should know. Again, multicasting, since we will talk about multicasting right here, you should know what is multicast. What is like in multicast, you should know what is like source specific multicast, what is like any source multicast. Basic multicast fundamentals you should know as well. This is covered in specifically CCIE Enterprise Infrastructure routing curriculum. So we will again talk about in brief what is SSM, what is ASM, any source multicast, source specific multicast. We'll talk in brief about protocols such as IGMP, detailed discussion because it's already done in CCIE Enterprise Infrastructure curriculum. So again, you should have the basic fundamental knowledge of multicast so that you can understand these multicast topics in SDA. We will again, it is not possible, multicast takes at least 2 weeks to cover, so it's just not possible to complete everything from the scratch regarding the multicast. So I will assume that you know at least some basics of the any source basic multicasting you know, If you don't know, just you can cover basic multicast from your CCIE infrastructure enterprise infrastructure book. Just basic multicasting will be enough. What is IGMP? What is multicasting? Basic things you can cover. Right. So basic multicasting you should also be aware of. Apart from that, wireless WLC AP we will cover in very limited amount. So even if you don't have any prior understanding of it, it's completely okay. Apart from that, I think like it's okay. Lisp is a new topic. We will talk about that. VXLAN is a new topic. We will talk about that. So no need to worry about that. But these are some basic things that you should know before you start your SDA curriculum. You should have routing, switching, security fundamental knowledge, and also like some multicast, knowledge to complete like these topics in our SDA. So even if you have basic understanding, it will be enough. It will be okay. Right. So we will start the labs, I think, from here from this point. So you will have like this much amount of time to complete like these basic routing, basic switching, basic wireless, basic multicasting, and basic like security topics. You will have like 8 to 10 days to cover all those things. Right. So I think that's pretty much it. That's all that we need to discuss from the content point of view. If you guys have any questions, you can ask. Let me know. Anyone, any questions? If you have, let me know. This is the content that we are going to cover. This is how we are going to cover it. This is the official content that we are going to cover. This is what we are going to focus more. And then all the rest of the things we will just cover in more like a brief discussion format. So this one and this one. So this is how we are going to cover the content. And this is like all these theory and labs that we are going to do. Any doubts, anyone? If you have, let me know.
Hi, this is Vinay. So which all hardware you are going to cover, like in terms of lab switches and router, something, or wireless
Yeah,
hardware?
we will be using as a hardware point of view. I will be using like one Catalyst 9300 series switch, and we will use 3 of 3850 series switches, all running compatible software for the SDA. We will create
Okay.
one branch of 3 switches. We will create one branch of 1 switch. We will have some user here. We will have some user here, and we will have like some traditional network as well built in EVNG software. And we will have the communication like from the SDA branches to the SDA branches to the traditional branches. And we will use just like routers, like for the routers, for the gateways and the border nodes and all, we are going to use the switches as well. When we need to connect like these SDA to the other rest of the network, we will be using like any basic router that EVNG has to offer. So the topology will be mixed on the EVNG and the physical one. So even we can use like any iOS like 15.x series router, and we can use like physical like these 93 and 3850 series platforms. As far as the WLC is concerned, we will have like 9800 CL for the wireless LAN controller, which is
Okay.
again going to be part of the EVNG itself.
Oh, okay.
So this is how the topology is going to look like. Let me, since we are talking about it, let me show you. This is how the topology is going to look like. So you get the better understanding of the lab as well. Wait. So okay. So this is the topology for specifically like our SDA, like branch 1 and branch 2. So here we have actually one branch where we have only one switch and a few LAN users. Here we have like total second branch where we have like 3 switches and we have like some LAN users. These branches are connected to the DNA center, to the ICE, to the NTP. Here we have a management switch that has connectivity, that is providing the connectivity from these DNA center, ICE, and NTP servers to these branches. It could have been a typical router as well, but we are going for the layer 3 switches. That layer 3 switch is providing the interconnectivity from the branches to the DNS center. So this one is specifically from the this that you see here. This is specifically from the branch 1 and branch 2 point of view. Like from branch 1 and branch 2. In branch 1 we have one device, in branch 2 we have 3 devices. This is going to be Catalyst 9300 series switch, and this is going to be the 3850 series switches. The underlying infrastructure will be built based on the EIGRP. Here we will have like multiple links between the switches. They will be bundled with the help of the Ether channel technology. We will have loopbacks here on all these devices. We will have the loopbacks. We will provide the reachability. We will make this reachable to the DNS center, ICE and NTP server. We will make this reachable to the DNS center, ICE and NTP server, especially the DNS center, so that the DNS center can manage all these devices and help us building the SDA network. So this is from the branch point of view. Also, I have one more topology. I'm not able to find it actually at the moment, but that topology actually shows you like how are we going to actually use it, how are we going to mix it with the traditional network. So I do have one topology that actually focuses on the traditional as well as this SDA network as well. Let me just quickly, because in some of the batches I must have shown that topology. Just a second. So in that topology we will have like a mix of like both traditional and the, just a second, we will have the traditional and the SDA network both. So I guess, let me, I'm not sure. I will show you later on. That basically like here, outside this we have like a traditional network that is connected with the rest of the network as well. Right, the traditional network is again built on the EVNG solution. So in EVNG, I can power on the EVNG directly. Just a second. Yes. Okay. So this is going to be the traditional lab. This is going to be a mix of traditional and the SDA, software defined access. Just a second. Let me show you. Yeah. So this is the topology that will have a mix of both like traditional and the SDA. So this that you are seeing here, this part that you are actually seeing here, this switch number 4 is actually here, site 1, and switch number 1, 2, and 3, this is right here. So this is one site, this is other site. It is connected to a router. It is also connected to a router. This router is providing the interconnectivity with the rest of the network. This you can assume as a data center. So this data center actually has a few devices. This is connecting like our traditional network with the like SDA network. So this is going to be our more like the final topology that we have. We have our DNS center installed somewhere here. We have ICE installed somewhere here. We have some NTP server, DHCP server. Everything is here in the data center. So when the end user gets onboarded, the end user must get the IP from the data center DHCP server. So this topology is going to be the final topology, which will be a mix of both traditional and the SDA network. This is specifically, this right here is specifically this one, and rest is completely traditional. I already have configured it. I will explain you like what things we have configured here, how the connectivity and everything is done. I will explain you that as well. And later on, I will also explain you that instead of using this traditional router, you could have used the SD-WAN technology here as well. This is the part what we refer to as the IP transit. IP transit basically means when we connect our SDA fabric with the other when we connect one site with the other site, when we connect one site with the rest of the network using IP as a transit. So traditional routers, we have BGP running. So that is what we refer to as the IP transit. We could have also used SD-WAN as a transit. That means instead of using these traditional routers, we could have used like SD-WAN routers here as well. So we can configure SD-WAN router, configure the SD-WAN router, this SD-WAN router, this SD-WAN router actually can form the IPsec tunnels and everything with other SD-WAN routers. So here we can use a mix of SD-WAN and SDA, which will give us an SDN solution for our campus network. We can use SD-WAN router and SDA, so which will give us the SDN solution for our campus network. In fact, in our data center, in the LAN, we are already running ACI Epic, and at the border, at the edge, we can configure these devices as the SD-WAN devices as well, and we can build our complete software-defined data center as well. So end-to-end SDN solution can be built in the environment as well, where your data center is already running the SDN solution based on the ACI Epic, and the border routers, which were earlier were traditional router. Now we have like SD-WAN routers in the data center at the border router. Here in a campus network, we had traditional network, but now we have migrated to the SDA. Then we have SD-WAN router, SDA, SD-WAN router. So end-to-end, a complete SDN solution can be achieved in our infrastructure. So this is the topology that is going to be, that is what we are going to focus on. So first we will build this, then we will build this, then we will talk about integration like handoff, and then we will see how the rest of the things will be there. Right? So from the lab point of view, that is like, what we are going to cover. Now, as the classes progress, you guys can practice and everything on the DCloud as well. So if you search like Cisco DCloud, they have already given you some demo. Just search Cisco DCloud, something like that. Just go to the Cisco DCloud. You can click on this button, Cisco DCloud, and here you can log in with your Cisco credentials. Just log in with your Cisco credentials, and let me log in. In this DCloud, they have given like a lot of demos that you can actually opt for. So once you log into the Cisco DCloud, here you can go to this catalog option from here. If you go to the catalog option from here, you can actually scroll down of the, you can see that here we have like a lot of demos. So we can click on DCloud, we can click on instant demo right here, and if you right here you can see the second demo is Cisco DNS Center Automation and Assurance version 2.3.5. So just click on this button. So if you click on this, you can click on view button. It will open the cloud delivered DNS Center for you. Here you can explore like everything that we are going to cover in the lab. Password, username, password is going to be like demo and demo 1234 exclamation mark. You can log in, and this will open the cloud delivered DNS Center, which is offered by Cisco DCloud itself. And you can, everything that we are going to cover, you can cover here as well, like almost everything. Right. So a few things we will not be able to do, but like, for example, setting the roles, exploring like options and everything you can do on here. So this right here is more like the demo that they have given on the DCloud. And on here, like this is the main graphical user interface of the DNS Center. And if you go here, you can see all the options. Similar options you will get in a real DNS Center as well. So you can design your network. You can create the policies for your network. You can provision all the things from one centralized point, and you can do the monitoring from one point as well. These are 4 workflows in DNS Center: design workflow, policy workflow, provision workflow, and the assurance workflow. Design workflow offers tools that you can use to design your network. Policy workflow offers the tools that you can use to create the policies for your network. Provision workflow offers the tool that you can use to discover the devices, add the devices to the inventory, use the things such as LAN automation, build your SDA network right from here. So under the provision, we have this SDA, and in the SDA, we have these variety of options. We can also integrate other services such as, for example, stealth watch, such as, for example, IoT services, such as, for example, umbrella integration. We can form site-to-site VPN tunnels, IPsec tunnels from one device to other device just in a few steps, few clicks actually. So these are some services that are offered by the DNS Center. These services you get under the provision workflow. And at the end, monitoring. Health of your overall network. Then you have like variety of issues, events that have occurred. If you have deployed any sensors, then this Wi-Fi capable devices, like we can do all the monitoring and related tasks from the assurance tool, assurance workflow that we have in the DNS Center. So everything like from the monitoring point of view, you get on here. We'll talk each and every, we will talk about like each and every workflow as a part of our training. These are 4 major workflows, and then we have some generic workflows as well. If you click on this workflows, we will have some generic workflows as well. Some generic workflows are here. They have added like a lot of new workflows here. For example, you don't know what is like how to configure the multicast. Let's say you have no idea on how to configure the multicast. Just click on this. It will open more like a guided wizard from where you can go through and you can configure the multicast. No configurations needed at all. DNS Center will push all the necessary configuration to the devices to configure the multicasting in your SDA network. So first thing, like select like where you want to enable the multicast, for example. So you will select like I want to enable the multicast in which location in San Jose, this location we want to enable the multicast. Then it will ask you like what kind of multicast are you going to use? Are you going to use native multicast or are you going to use this thing called hidden replication? Let's say for example, you don't know what is native multicast, what is hidden replication. Right here they have explained what is those things. We will talk about that as a part of our training as well. But let's say you don't have any idea, you can read it to get a basic idea about the hidden replication or the native multicast. So let's say for example, if you go for hidden replication, click on the next button. Like for which virtual network, for which VRF you want to enable the native multicast or the hidden replication. So I want to enable the multicasting for this VRF, for this VN, I would say. Then multicast pools. So in multicasting, we use an IP address. So basically, it will, it will take you through a guided demo. Then it is asking any source multicast, source specific multicast. It will take you to a guided demo, and if you just complete this workflow, done. As soon as you click on the next button, it will deploy the multicasting in that particular branch. All the configurations that are needed will be pushed by the DNS Center into that particular branch. You don't need to go through like, you don't need to cover any configuration. You don't need to do any configuration by yourself. All you need to know what is multicast, how the multicast works, and what are the options available regarding the multicasts are there in DNS Center. That's it. Just click on next, done. So this is what we have here under some generic workflow. Similar to that, you don't know what is site-to-site VPN. Just click on this site-to-site VPN. It will ask you VPN name, from what site to what site you need to configure the VPN. Done. Click on next button. It will ask you a few more things. So choose the site where you want to configure the VPN, select the pools and where you want to configure the VPN, then configure encryption, authentication and those things, and done. So it's more like a guided workflow. These are like guided workflow that we can, these are some other like workflow options that we get here. These options like allow you to configure things even if you don't know about those things in a very detailed way. Remember that you will not have access to all those things, so you have to see accordingly, but most of the things you will be able to cover from here as well. right? Then and again, like let's say for example, you are also, let's say you are not able to understand from here as well. Let's say like even these workflows, they are not making that much sense. So here, right here in the DNA center, it is a very powerful tool actually. Here, right here, at this point here, they have given an option called interactive help. So if you click on this interactive help button, it will open this kind of like workflow. And let's say for example, we want to add a new device to the site and we don't know how to do it. So just click on this button, it will show you how to do it. So next, so it says like click on there. So it clicked on there, it says click provision, then it says click inventory. It is basically telling us like how to, for example, add a device into the site. Click here, it says like hover the cursor over the drop down menu and choose inventory. So hover the cursor here and choose inventory, right? Next. So it's more like, again, use the check boxes to select the required devices. Okay. I have selected the next. Hover over the cursor to action buttons, then go to the provision and then go to the assign devices to the site. Right. Next. So select like where you want to assign this device to. Select the site like everything. Once you have selected the site, then click on the save button. Click on that. It is more like giving you a guided demo. It is available in the real DNA center as well. This is the real DNA center actually.
Yeah.
So just assign, enter the task name and everything. So basically you can go through this guided demo actually. Even if you don't know anything, you need some help, you can get the help from this interactive help option that they have. This is like that. You don't know, like for example, how to configure these things. You can just click on this button and it will just guide you in this screen as well, that okay, here you go here and create like these things accordingly, right? So you can just take the help from there as well. We'll explore these options later on, but the whole point is that we can take this guided demo from here as well. So you will be able to do everything that we are going to do in our lab on here in this DCloud DNA center. You can configure, you can define the rules and everything. You will be able to do it here, right? So this is from the lab point of view. Right, so this is like everything that you should know before beginning our content.
Everybody has access.
Everyone has the access. All you need is a valid Cisco credentials.
Okay.
And you can also, I guess you can, there's also the Cisco DevNet sandbox. So if you want to book a lab, you can also book a lab there as well. This is like instead of DCloud, we can have like DevNet sandbox lab actually. So here also you will notice that you can actually, I'm not sure, I might not be allowed to do that, but you can also build you can also schedule a lab for the DNA center, and then you can do the lab at the scheduled time actually. So from here you can also book the lab for the practice purpose. They have given more like a demo that you can have. Right, in this option, in this DC, they don't have that, but they have that. They do have that DevNet DNA Center lab in the in the DevNet sandbox. Something like that, I guess. So just search DNA Center DevNet sandbox, and here you can log in again with your Cisco credential, and here you can explore the options as well. I'm just telling you how can you do the labs if you want to do it. So here we have documentation, learn and everything, technologies, networking, SD-WAN, wireless, like all these things are actually available here. So you can just explore Cisco DNA Center platform, click on this, So they have like some demo labs on here as well, right? So here, learning lab, sandbox, coding and everything. So click on the sandbox, and this is the lab, right? So this is the lab. How can you access the lab? Here, you need to download AnyConnect VPN and all that. So this is like you can reserve this lab actually. You have to reserve this lab. Then once you reserve this lab, then you can spin up the DNS center and do the labs from here as well, right? So they have given us a lab as well in the DevNet sandbox. If you want to explore the options from here, you can explore the options from here. So here they have like switch number 1, 2, 3, 4, and some end users. So there's 4 switches are there connected via the internet, connected to the DNS center, and some 2 end users are here. And here you can practice things such as device onboarding, host onboarding, and those things you can practice on. You do have to schedule this lab. You have to reserve this lab for a particular time slot, and then you will be able to do the lab at that particular time slot. Right, so sandbox labs, go on the sandbox labs and then reserve the sandbox lab as per the requirement. So go to like sandbox labs, and where is your DNS center? Cisco DNS center here. So click on the DNS center and you can just reserve it. Or if you want to just explore the option, you can just click on this always on. This is always on. This one is always on. So you can either reserve the lab and practice it later on, or this one is which is like always on lab as well. If you want to focus, let's say for example on the ICE integration here, Cisco DNS center with ICE. This one is the DNS center with the ICE. So just go through these options. Like if you want to do the labs, you can just click on this one as well, and it will open the DNS center, always on DNS center, and you can just explore the options from here. Right, open this here, log in with this username. Wait, log in with this username and password, and it will open as an always on DNS center, and you can manage the things from there. So DevNet user and password Cisco 123 exclamation, I believe. Yes. So this is an always on DNS center. So here you can explore the options as well. So DevNet is one place that you can look up to schedule the labs and do the labs as well. Or you can just explore the options of the DNS center from there as well. Right, so this is also an option. So these switches are on. These switches, this DNS center is already on. So you will be able to manage those things from here. You will be able to check. This is the topology actually. You will be able to explore those options from here. Right, so completely up to you which option you go for. You can go for the DCloud, or you can go for the DevNet sandbox to schedule the lab and do the labs from your point as well. Right, so this is from the lab point of view. Okay. Again, any questions, anyone? Let me know. I guess this is an old version of the DNS center. Yeah, 2.3.3. This is 2.3.3. This one is 2.3.5. So a few more options are here, as you can see. A few more options are here, such as for example zero trust overview, which option is not here actually here in this one. So with every release they add a few more options, so you might not see all the options in the older releases, such as LAN automation is there, but here in the new version they have given a dedicated tab for the LAN automation. Otherwise what we need to do, we need to go on here, we need to go to the Fabric site and inventory, and then from there we need to go for the LAN automation. So again, like they play with these like options here and there. So options are available, but some options might not be available exactly at the same place in the new version. So you need to, based on what version you have in your production environment, you need to explore the options in your DNS center tool. So with every release, they add some new versions, some new options. So those options you can explore as per your requirement. Right, so we will be working on this one. We will be working on 2.3.5. This is the one that we have here. on premises. So this is the one that we will be working on. Our focus will be on this SDA. As a part of our content, our focus will be on this SDA, how to design the network, how to create the policy, how to provision the network, inventory management and everything. But our focus will be on the SDA. And additionally, we will talk about things such as, for example, wireless, multicasting, APIs and everything as well. So API documentation and everything we will talk about later on. Right? Any questions, anyone? Let me know. This is like all the things that we should know before we begin our content. Any question, if anyone has, let me know. Yes, Utpal.
Hello, hi, good morning.
Yeah, morning.
Yeah, so just want to check in our organization, we have this ACI, how they manages. Is this manages by the SDA?
No, they have their, for the ACI, they have a dedicated controller referred to as EPIC. So you need to study about the EPIC controller, which is quite similar to the DNS Center. In fact, DNS Center is the enterprise version of the EPIC. So ACI infrastructure is managed by the EPIC, is application policy infrastructure controller. This is some other controller for your DC environment.
Okay,
Yeah.
got it. Thanks.
Any more question, anyone? Let me know. Remember that our content will specifically be focused on CCIE Enterprise Infrastructure lab exam.
Yeah, in SD-Access, we can integrate ACI and we can monitor all the data center and in and out traffic.
Some limited options are there. ACI integration, for the ACI integration, some limited options are there that needs to be explored. What options are available in our DNS center for ACI integration? So a few things we can do, but not all the things, not at least yet. Maybe in some
No, at least monitoring perspective in and out traffic, we can monitor.
you need to explore the options in the DNS center. If you have any such option, then yes, otherwise no. So we don't have like a lot of options in our DNS center from the ACI EPIC point of view. Just basic integration can be done, but what things you can monitor and not, that you have to see. Ali, I'm not able to hear you, just in case if you're saying something.
Hey, good morning. Can you hear me?
Yeah, now I can hear you. Yes.
Okay. So the scenario or the lab that we will study here, is it kind of similar to the one in the exam, in the lab exam?
Not quite yet, but you can expect the similar kind of. Any more questions, anyone? Let me know. In that case, if everything is okay, let's start a few things at least today from the SDA point of view. And again, for this, I would recommend you to go through this book. This is already there in the portal, and you will also get the recording after the classes. So you can revise it from there as well. But I would recommend you to go through this second book, actually, this one. I would recommend you to go through this book for the discussion of like why we need SDA and all those things. We'll talk about, which we are going to talk about just now. So you can refer to this book first. Once you get to know the fundamentals, then you can refer to this book actually. So here they are talking about like what are the challenges that we have in a modern day network. Here also they are talking about the same. This one is like much more precise. It's more like point to point. So I would recommend you to go through these ones, then go through this one. Right. So let's now talk about from the content point of view. Let's now talk about like what is SDN, software defined networking, and what is this SDA solution, and what challenges this SDA solution is going to solve in our campus area network. Right. So modern day network that we have, it faces like quite a few challenges that one must overcome. Those challenges can be categorized as the operational challenges, and those challenges can be categorized. Some challenges can be categorized under the operation challenges, and some challenges can be categorized as the security challenges. So we have like a few issues, we have a few problems that we get in our modern day network, which we actually did not have in our traditional network, but we do have a few challenges in a modern day network, and those challenges can be categorized as network operation challenges, and we have some security related challenges as well. So some common challenges that we face, some common challenges that we have in our traditional, there are many challenges in today's network in managing the networks because of manual configuration and fragmented tool offering. What does it mean? It means like in current network, we do all the configurations and everything manually. Some companies, some organizations, they use variety of tools, but those tools vary from organization to organization point of view. Some organizations, they use some set of tools, some organizations use some different set of tools. So one cannot just know these tools and practice on these ones. So we have fragmented tool offering, which means that we have different tools used by different organization, different tools used by different organization. There's no common tool to manage like all these configuration challenges from one single point. So different organizations, they use different tools. Different organizations, they use different tools to manage the campus or enterprise network, and those tools are like different since those tools are different on per organization basis, which is what we are going to refer to as the fragmented tool offering. Also, the organizations, they might have different tools for monitoring. The organizations have different tool for like configuration management. The organizations can have different tool for like upgrading the operating systems and all those things. So fragmented tools also like means like we can have different tools for different operations. We can have different tools for monitoring. We can have different tool for configuration. We can have different tool for upgradation and everything. We can have different tools for different tasks. And the challenge is where these manual configurations, these manual operations are slow. It takes time, error prone, because these are done by us humans. So there are possibilities of errors in the configurations that we are doing manually, and these are proving to be ineffective in a modern day network because of how the modern day networks are actually built. So based on like how the modern day networks are built, these manual configurations are proving to be very ineffective. So what are these challenges that we have in our modern day network? One of the challenges that we have in our modern day network is actually based on like configuration challenges. Let's say, for example, we have n number of branches. We have a few like n number of branches, data center, headquarter. We have n number of locations where we have our infrastructure built. Now the point is that we need to configure the devices in these branches, data center, headquarter, and the other locations all by ourselves. We need to do the manual configurations. We need to configure all these devices manually by ourselves. Why? Because like configurations that we are going to do on one of the device, they are not automatically going to be sent to the other devices. So we need to configure like first, for example, we need to configure like one router, then we need to configure the other router, then we need to configure the other router. It's not like we can just configure one router and the configurations are automatically pushed onto the other devices. Until we use some sort of automation tools, this is just not possible. If your company is using some automation tools, then it is possible that we can push the configuration from that tool, and those configurations will be delivered on multiple devices at the same time. Otherwise, if you are doing the manual configuration, this is just not possible, that the configurations that we have done on one device are automatically propagated onto the other devices. So the point is that if you have n number of devices to configure and you are going to do the configurations manually, it is going to take too much time. It is time consuming, it is prone to errors. Because we are doing the configurations ourselves, there are possibilities that we can do some mistakes in the configuration. Even though you are just doing the copy paste, maybe we need to configure BGP on all these routers. We just did show run pipe section router BGP. We copied the BGP configuration and we pasted those configurations on these router. We forgot to change, for example, router ID. We forgot to change, for example, like neighbor ID. So configuration, even in copy pasting, the configuration might go incorrect because of the human errors. So when we do the manual configurations, configuration is always prone to errors. And more importantly, we will need to do the configurations on all these devices one by one. There is no centralized point of control until we use some automation tools. The configuration changes or configurations need to be done on all these devices completely manually. And manual configurations are always prone to errors. So you will spend like quite a lot of time in finding out where exactly the problem is, and you will spend quite a lot of time in correcting those errors as well. So overall, it is going to be slow, very time consuming process. In traditional network, we have every device, basically every device has its own control plane, data plane, and management plane. In traditional network, in traditional devices, every device has its own set of control plane, data plane, and management plane. So for example, we have 3 routers. Every router has its own set of control plane, management plane, and data plane. Control plane, management plane, and data plane. Control plane, management plane, and data plane. Since all these devices has its own management plane, we need to manage all these devices one by one. So we need to take the management access of router number 1, then we will use the console port, auxiliary port, or the telnet, SSH, SNMP, whatever. Like we will use variety of tools to take the management access of that device. Then we will do the configuration. And then if you want to do the same configuration on the other device, then we need to take the access of this device separately. So since every device has its own set of management plane, all these devices, every device needs to be managed separately. Since every device has its own set of control plane, management plane is responsible to deal the management traffic. It deals with how the device is being managed. Management plane deals with how the device is being managed. Management plane deals with like how the device is being managed. Are we managing the device via telnet, SSH, SNMP, how the device is being managed. So that is the management plane. Since everyone has its own set of management plane, every device needs to be managed individually. Since every device has its own set of control plane is responsible to build variety of tables such as routing table, such as topology table, such as like database table, such as like BGP table, such as like STP. These variety of tables that are needed to take the forwarding decision, these tables are built by the control plane of the device. Control plane is responsible to exchange these messages such as OSPF messages to exchange the database, such as EIGRP message to exchange the route, such as BGP message to exchange the route, such as like STP messages to decide who is the route bridge and all. So control plane basically of the device, controls like how the data is going to be forwarded. Control plane of the device is responsible to build a variety of tables that are required for the data forwarding purpose. And since every device has its own set of control plane, it's just not possible that we configure the OSPF here and we don't configure OSPF here, and or when we configure OSPF here, the OSPF is automatically configured here or here. We need to configure OSPF here as well as here as well as here. Then the neighborship will form, route will exchange, and then this control plane will know how the data has to be forwarded. Then the control plane will know how the data has to be forwarded, and this control plane will know. Since every device has its own set of control plane, every device is going to build its own set of tables to decide how the traffic has to be forwarded. So control plane is also like distributed. Everyone has its own set of control plane. And also everyone has its own set of data plane. Data plane is the part of the device that actually performs the data forwarding. Data plane uses those tables built by the control plane to decide like how the data has to be forwarded, and it actually forwards the data. Data plane of the device is responsible to forward the data from one interface to the other interface. Data plane uses the tables built by the control plane to decide how the data forwarding has to take place. And since every device has its own set of data plane, it is just not possible that here we have the routes, but here we don't have the route, or here we don't have the route, and still data forwarding can. It's just not possible. Every device must have the route. Every device must have the information on how to forward the data, and then that device is going to forward the data accordingly. So point is that every device has its own set of control plane. Every device has its own set of management plane. Every device has its own set of data plane. That is why every device needs to be managed individually. On every device, we need to configure some protocols so that they can exchange the information. And every device has its own set of data plane. That means every device will use the variety of tables built on those devices to make the forwarding decision. Distributed some sort of architecture we follow in the traditional network. And that is also one problem, because we need to do the configurations, we need to manage, and we need to build those variety of tables on all the devices one by one. It is just not possible that you take the management access of one device and able to configure all the devices from there. It's just not possible. It is just not possible that we configure OSPF on one of the router and it will configure OSPF on all the router, or exchange the route on all the router. It is just not possible. If you have n number of devices, you need to take the management access of all those n number of devices one by one. You need to configure some routing protocol on all those devices one by one, and then you need to make sure that every device has appropriate routes in their routing table so that every device can forward the data, and that thing also has to be managed one by one on all these devices. So since in a traditional network we have distributed architecture, every device has its own set of control plane, management plane, and data plane. We need to manage, configure all these devices individually. This is also one of the challenge that we have in our traditional network. So one challenge, again, why that configuration related challenges were there? Because like every device has its own set of control plane, management plane, and data plane, basically because of which every device needs to be configured and managed individually. Also, you don't only have the wired devices in your infrastructure. We have wired and wireless devices in the network. Modern day network is built around the wired and wireless infrastructure. Users can connect to their desks in a wired fashion, and users can also use a variety of like wireless devices such as their laptop, such as their mobile devices. They can also use variety of wireless devices and still be connected to the infrastructure in a wireless fashion. So a user can connect in the network with both like wired and wireless way. A user can connect to the network in wired and wireless way. How are we going to manage the policies for the users that connect via wire and the users that connect in a wireless fashion? Basically, we need to configure two different policy, one policy for the wired user, one policy for the wireless user. So when the user connects with the help of a wired network in our topology, then the policy will be applied, and when the user connects in a wireless fashion, then a different policy will be applied. So basically, the point I'm trying to make is that managing the wired infrastructure is going to be different than managing the wireless infrastructure. We will have wired engineers, we will have wireless engineers, people with the knowledge of the wired infrastructure, people with the knowledge of wireless infrastructure, and these will be responsible to create the policies and everything regarding the wired, and these people will be engineers will be responsible to create the policies regarding the wireless infrastructure in your network. So the management of the wired and wireless infrastructure is going to be managed by two different entities, two different people, which is again going to impose some complexity. A user that can connect with wired and wireless, both the technologies, it will have a different policy for wired and a different policy for the wireless connections. So managing the infrastructure that has a both wired and wireless infrastructure is also going to be a time consuming process. We have to deploy 3 new branches, and in these 3 new branches we have to configure like in every branch we have total 3 switches and 2 routers that we have in every branch. In every branch we have 3 switches and 2 routers that we need to deploy, and we have 3 small branches to deploy. Basically total we need to configure 15 devices. So when we have to deploy, like let's say a few new branches, when we need to deploy a few new devices, this could be like wired devices, could be wireless devices. Even if you are going to do some copy pasting from existing branches to these new branches, it is going to take quite a lot of time. User must log into all these devices one by one. Admin must do the configuration on all these devices one by one. Admin must troubleshoot any challenges, any problems that come on all these devices one by one, which is again going to take some time. Deploying a new device in your infrastructure or deploying a new branch, headquarter, data center in your infrastructure is going to also take some time. And also, this is going to be a little bit complex process. There are again chances of errors. Again, why? Because we are deploying these new branches all by ourselves. There is no automation tool. There is no tool to manage that infrastructure from a centralized point. Since every configuration we are doing manually, it again might be prone to errors and all. So in short, deploying new devices in your infrastructure is going to take some time. And again, configurations might be prone to errors as well. Even if you do just copy pasting, still the problems you might face. So that is also, there are some challenges in the deployment of the new devices as well. And do not forget the security related challenges. Security related challenges means we have n number of branches at quarter data center. We have different types of users, such as, for example, we have guest users, we have our corporate users, we have some new IoT devices as well. Some people are accessing the internet. Some users are, some corporate users are allowed to exit the internet directly instead of going to the data center or so. Some users in our corporate network are accessing those cloud delivered applications or infrastructure. Basically, we have different types of user in our infrastructure. How are we going to enforce the security for these different users? How are we going to control what users can communicate with what user and what users cannot communicate with what users and services? So is this guest user allowed to communicate with the IoT devices, or the guest user is allowed to communicate with these cloud delivered infrastructure? Guest user is allowed to communicate with the corporate user. Corporate users are allowed to communicate with this one or not. So we need to handle, based on different types of users, we need to handle the security as well. How are we going to enforce the security? We can enforce the security based on things such as ACL. We can configure ACLs. With the help of ACL, we can control who can communicate with whom and cannot. So, for example, guests cannot communicate with the corporate cannot communicate with the guest. We will configure some ACLs. In that ACL, we are going to define the statements. Those statements will have the entries on what devices can communicate with what devices. However, configuring ACL in a medium to large scale infrastructure is again going to be a very time consuming process. And the management of the ACL is very complex, because if you need, and a typical ACL can have, let's say, for example, 4,000, 5,000 lines. And if you need to edit one particular statement, you need to add one particular statement, remove particular statement, it is going to be a very complex task in case of ACL. So we can enforce the security based on the ACL. We can also enforce the security based on the VLAN. Such as, for example, we have our switch. In this switch, we have our corporate users and we have our guest user. We can put these users in a different VLAN, put these users in different VLAN. They will not be able to communicate with this, because one VLAN to other VLAN communication is not allowed. We can also enforce some security based on the VLAN, but the problem is that VLANs are limited in number. Maximum 4094 number of VLANs are there, out of which VLAN 1, 1002 to 1005, these are reserved. So limited amount of VLANs are there, and based on our requirement, we might need more than that much amount of like VLANs, or maybe, for example, later on, there is such requirement that we need to perform the communication in between the VLAN. Like for example, VLAN 1 should be able to communicate with VLAN 100. VLAN 2 should be able to communicate with VLAN 100. Why? Because in VLAN 100 we have some servers. Those are accessible to the corporate, and those are also accessible to the guest user. But we still need to make sure that these corporate and guest users, they do not communicate with each other. So the point remains the same. Even if you configure the VLANs to perform some sort of segmentation, since VLANs are limited in our infrastructure, we might run out of the VLANs, or when we perform things such as, for example, inter-VLAN routing, the communication between the VLANs will also be successful, which we need to control again with the help of access control list. So even if you configure the VLANs as simple as a topic called VLAN to enforce some sense of security in our network, it is also going to be complex to manage the VLANs in a large campus area network. End-to-end VLAN deployment or local VLAN deployment, different types of VLAN deployment options you can follow, but still it will be hard to manage those VLAN infrastructure in a medium to large scale campus network. So security related challenges are going to be there in our infrastructure, in our network as well. Then we have, of course, variety of operational challenges. Everything is up and running, everything is okay, everything is up and running. Suddenly some user reported, a few users have reported that they are not able to access the internet services, or they are not able to access the corporate servers. So what you need to do, you need to now find out what is the problem. You need to spend some time to rectify, to find out the errors, find out the mistake that you might have done in the configuration, or you need to find out like where exactly the problem is, based on which these users are not able to connect to the internet or the corporate servers. Maybe some incorrect ACL you have applied, maybe some incorrect VLAN you have applied, maybe routing is not done properly. You need to find out the problem, and then you need to give the solution based on the same. So companies spent like a lot of time in resolving operational challenges of the organization. So they spend a lot of time and money, both like in resolving those variety of operational challenges, such as, for example, troubleshooting the network connectivity issues. So basically, how are we going to T-shoot the network if someone reports a problem? You need to gather all the possible information. You need to gather the logs. Maybe you need to ask, you need to query the users. You need to ask the users like, okay, what is the last time, for example, you were able to access the internet? Did you do some changes after that? Are we getting the IPs or not? Basically, you need to question your users who are not able to access the internet or the corporate services. You need to check the logs, check the users, check the servers, check the applications, check the security. You need to first of all collect like information, and then you need to check based on that information variety of things to find out the problem and give a proper resolution of the problem. So operational challenges are also going to be there. What about the vendor? It's not like the companies are going to use only Cisco devices. Company can use Cisco, Juniper, Alcatel, other vendors as well, Huawei, HP. So companies can use, for example, different vendor devices. Different vendors have different operating systems. Different vendors have different, for example, operating systems. So you need to find the people, you need to find the users You need to find the candidates who are well versed with Cisco iOS, Juniper operating system, Huawei, HP, users who are well aware from that vendor command line interface. You need to find the users based on the same. So the problem is that companies are going to use like different vendor devices, and every vendor, like for example, Cisco vendor, they might have some set of tools to manage the Cisco devices. Juniper vendor might have a different set of tools to manage the Juniper devices. Huawei, HP, these vendors might have different tools to manage their set of devices. A user must be aware of all these tools so that they can manage a multi-vendor environment of the organization. So some sort of like if you are using multi-vendor deployment, in that situation, you will also face the challenges, you will also face the problem in managing those different vendor devices. For example, you might know, for example, in Cisco, this is a Cisco switch and this is some other vendor switch. Remember that in Cisco switches, we have this concept called PVST. We have the concept of PVST plus. We have the concept of rapid PVST. And in other vendors, we don't have such concept. We have just STP. We have just RSTP. How these are going to communicate to each other? The point is that there are some protocols that are more like proprietary to Cisco. Like Cisco vendors can implement things such as PVST, rapid PVST, but other vendors, they can just run STP or RSTP. So how the interoperability is going to be there? You need to find out like a way so that these Cisco switches can communicate with these other vendor switches. Some interoperability, some way you need to find out based on which these devices can be able to, or these devices will be able to communicate with the other devices. And of course, like I said, Cisco devices are going to be managed in a different way than, let's say, for example, HP devices or the Juniper devices. So management of Cisco devices is done in a different way than the HP or the Juniper devices. They might have their own set of tools. They might have their own set of tools for the management purpose. So again, same thing. We have different tools, fragmented tool offering. We have different tools to manage the configuration on Cisco, HP, and other vendors. One must be aware of all those tools to manage the multi-vendor environment in the campus area network. So like we can go on and on and on, and we can list like a lot of challenges. And let's not forget, since we are talking, let's not forget about the cloud. Things nowadays are moving into the cloud at a very rapid rate. Like companies are opting for like cloud deployed infrastructure, which is what we refer to as infrastructure as a service. Companies are not spending a lot of money in building the infrastructure of their own. They are just getting the services from the providers such as AWS, such as Azure, such as Google, such as Alibaba, such as other cloud service providers. Companies are not building their own infrastructure. They can now opt for the infrastructure from these like cloud service providers. Cloud as a service nowadays we can use, such as infrastructure. Companies are not even deploying the applications on their local machines. For example, a very basic example, such as, for example, CRM applications, such as, for example, your basic example, such as Office 365. Earlier, company has like n number of machines. Every machine will have Microsoft Office installed. Someone has to install Microsoft Office on all these machines. Someone has to activate that Microsoft Office. Someone has to troubleshoot each and everything one by one if someone is facing the challenges. But nowadays, companies just can go for this Office 365 subscription for their organization. They can give a user ID and password, and people can work directly onto the cloud delivered Office 365 services. So this software, Microsoft Office, can now be accessed as a service from the cloud as well, such as Google Drive, Dropbox, You don't want to store the things on your local machine. You can upload it onto the cloud and you can access it wherever you want. So how are we going to connect? How our users are going to connect to those cloud delivered infrastructure and cloud delivered services? We have deployed some business critical applications onto the cloud, and now the users are saying that they are facing some latency challenges. They are saying that the application is running very slow. So find out the issue, why the application user experience, why the user experience for that application is not good. So you were checking, after 2-3 hours of checking you found out, or after some checking you observed that on the link that is going towards the internet, the FTP traffic is being sent a lot. Actually looks like someone is either downloading the file or uploading the file from the internet using protocols such as FTP, TFTP, HTTP, whatever. It is the user is uploading a 20 gig file which is consuming a lot of bandwidth, because of which the application user experience has gone very bad. So find out why the application user experience is not okay. It is like not working. The applications are not working properly or facing the challenges such as loss latency and jitter. You can again let's not go very far, but the point is that in modern day network we have a lot of challenges. And if you summarize all these challenges, you can summarize these challenges into two options. We have the challenges that are categorized as network operational challenges and the security related challenges. With the growth of users and different device, let's not even talk about the mobile devices, the IoT devices, the sensors, the cameras, and different types. Earlier, like humans were the only users of the network, but nowadays, apart from the humans, machines are also the users of the network. Machines such as, for example, CCTV camera, machines such as, for example, your IoT devices, smart home gadgets. These all are users of the network nowadays. Humans are not the only users are the network. So let's say we have deployed a 50-60 CCTV cameras. Let's say we have deployed some IoT appliances, some sensors in all our infrastructure. How are we going to manage? How are those devices going to interact with these network? So it just says that nowadays we have different types of devices into the network. Configuring user credentials, maintaining consistent policy across these devices is going to be complex. You need to configure a different policy for the wired user, different policy for the wireless user, different policy for the IoT devices. Basically, configuring, maintaining these different types of devices is going to be a little bit complex. In short, pace of change exceeds the human scale. The rate at which changes are happening, they are exceeding the rate at which the humans can handle those changes. These are two major challenges that you will face in the network management. One is going to be like network operations related challenges and security operations related challenges. And network cannot respond quickly to evolving business needs if the changes need to be done manually. Such modifications take a long time and are error prone. In short, we have n number of challenges in our modern day network, and we needed a way to solve these challenges. If not all, at least be able to solve most of these challenges. And this is what our software defined networking has done. Effective network segmentation can be exceptionally difficult to achieve in a complex network with variety of users and devices requiring different access privileges. It just says that we have different types of devices. Different types of devices require different types of policies. Different types of users have different privilege level. Segmentation, a proper segmentation in our network is going to be complex because we have variety of users, variety of devices. All those devices require different type of policies. All those users different type of privileges. So it is just going to be complex to manage the network. Traditional IP-based methods with firewall, VLAN, ACLs do not scale and not efficient in responding the real-time needs. We can configure the VLANs to perform the segmentation. We can configure the ACL to perform the segmentation, but it will take like a lot of time in managing those VLANs and ACLs one by one. Bottom line is that today's network do not address today's business needs effectively. As per some R&D, 95% of network changes are performed manually still to the day. 75% of operational expenses are spent on change and troubleshooting. 70% of operational expenses to the capital expenses ratio is 3:1. 75% of the operational expenses are spent on changes and troubleshooting. 70% of policy violations are due to human errors as per the reports. But since then, companies have started deploying things such as software-defined networking and all that. So this ratio has gone a little bit low nowadays. But still, before the introduction to the software-defined networking, this was there. So 3:1 ratio of operational expenses to the capital expenditures on network operations, labor, and tools. Like 3 times more money we are spending on the operational expenses rather than the capital expenses to the organization. So basically, they needed a way to address these variety of challenges that we have discussed so far. So they thought, why don't we don't do all the things? Why don't we create softwares? Why don't we create some software that perform configuration, that manage the network, that do things for us? So they created softwares. They introduced the use of software in our networking. Hence the name software defined network. Basically, software defined networking, SDN. Software defined networking is software defined way or use of software to manage our network infrastructure is what we refer to as the software defined networking. So in SDN, we use variety of softwares to manage our enterprise network. It could be enterprise local area network or campus area network. It could be enterprise data center. It could be service provider. It could be any type of network that we want to actually manage. So what is software defined networking? Software defined networking is software defined approach to manage the LAN and WAN devices of our campus area network. So of course, if you are going to use some software, you need to install that software somewhere. You cannot just use software. You have to install this software somewhere on some device. You need to install that software, and the device, the hardware where we install that software is what we refer to as the controller. So controller based networking, software defined networking is also referred to as the controller based networking. Controller is just the hardware where the software has been installed. The software is responsible to manage, basically configure, manage, and do everything in the network. And controller is just more like controller that we have. Controller is just more like a hardware where we have installed that software. Software is going to do all the things. Controller is just a way to run that software onto the device. So software defined networking can also be referred to as the controller based networking, where we use the concept of controller to manage our networking infrastructure. Controller is just a hardware running a piece of software that is responsible to manage the enterprise infrastructure in a proper way. Right. So this is now what we are going to talk about. So we'll talk about what options are there, what options are offered from Cisco when it comes to the SDN, and then we will specifically move on to the SDA solution. To overcome the challenges that we discussed in the last class, what they did, they decided to implement the software defined approach to manage the network, where the engineer is going to use some software to configure the entire network with the help of some softwares. The enterprise network, the data center network, campus LAN, WAN network can be managed. So hence the name software defined networking. So software defined approach to manage the network is what we refer to as the software-defined networking. In the software-defined networking, what engineer actually does, the engineer will more like go into the software. The engineer is going to give its intent to the software. Like engineer is going to tell the software what it wants to do, and the software is going to configure that thing on all these devices that we have in our enterprise network. So engineer doesn't need to log in like on all these devices one by one. The engineer just need to give its intent. Engineer just need to define what it actually wants to do, what it actually wants, what kind of topology, for example, it wants to achieve and all. So engineer is going to configure its intent onto the software, and the software is going to configure the devices, by the means of some protocol, such as, for example, SSH, such as, for example, netcon, such as, for example, some other, techniques. So in software-defined networking, basically, we use a piece of software. We use like a piece of software, and that software is going to be like that software will run on some hardware, such as, for example, DNA center. DNA center is one of the controller. DNA center is a hardware where they run this DNA center software image. Then the engineer takes the access of the DNA center. It goes to the graphical user interface of the DNA center, and from there it configures its intent. It configures what it wants to do. It has like the company has like a lot of sites. Engineer can configure its intent that they want to configure certain things on two sites but not configure on the other side, and then this program, this software, this DNS center, for example, this controller is going to take that intent, and this software is going to configure the devices based on what engineer has actually to configure. So software-defined approach to manage the enterprise network or the service provider network or the data center network is what we refer to as the software-defined networking. So in the software-defined networking, we use the softwares to manage the network. Now, there are three different SDN solutions. One is what we refer to as open daylight. APIs will be covered in the very end, but as our content specifically focuses on like GUI part of it, we will not talk about like APIs in very detail. It is specifically part of the DevNet certifications. Right, so we will talk about in brief, but not in very much detail. So there are three different SDN solutions and network programmability solutions available from Cisco. So one is referred to as Open Daylight Controller, like Open Daylight Controller based on Cisco Open SDN Controller. Based on this Open Daylight Controller, they had this controller named as Cisco Open SDN Controller, which is referred to as OSC. However, this is now obsolete. So you most probably will never see this controller being used in a production environment. For the data center network, what they have, for the DC network, for the data center infrastructure, they have this controller called EPIC, Application Policy Infrastructure Controller. So EPIC controller is for the ACI infrastructure, Cisco ACI, Application Centric Infrastructure for the DC network. Typically what happens, all these data centers that we have, these data centers are built around some applications that they serve. For example, like a company has a data center, and that data center is going to have quite a few switches. Those switches could be like for example, Nexus series switches and all. We can use different tools to manage that data center network. One being this EPIC, Application Policy Infrastructure Controller. So EPIC is one controller. EPIC is one of the controller that we have in our ACI data center. So for the application-centric infrastructure, data centers are typically referred to as the ACI data centers. Why? Because they are application-centric. They are built around certain sort of applications that they serve. So since the data center networks are built around certain applications that they serve, hence the name application-centric infrastructure. And to manage this ACI data center, we have a controller referred to as the EPIC. EPIC stands for Application Policy Infrastructure Controller. It was a very popular controller, like still like in modern day network, we use this EPIC controller in our data center infrastructure. In fact, Cisco offers you, if you want to just get started with this EPIC controller, you want to know in and out of the data center infrastructure, Cisco offers this thing called EPIC Simulator, ACI Simulator basically. There is this tool called ACI Simulator that you can download from Cisco, and you can run it on a virtual machine. That ACI Simulator is going to come with some like some pre-defined some switches and all, and you can just play around with like basic functions of that Epic controller within this software image. Like it's just for the simulation purpose, not in the real world. So once you get your hands on this ACI simulator, once you get to know how the ACI works, how the Epic works, then you can deploy the functions, then you can deploy this Epic in the data center infrastructure accordingly. So just for the simulation purpose, they have given us this ACI simulator, which you will study someday in data center track. So for the data center network, they have this Epic, ACI Epic. ACI is the name for the data center network, and Epic is the controller that they actually use to manage this ACI data center. So Epic is one of the controller. Then that MSO that we are talking about doing that is like, if I am correct, that is referred to as like multi-site orchestrator. That is like to more like the for the Nexus switches, it works more like as a dashboard for like managing multiple sites from one point. So that is a different thing, and this Epic is different thing. Hopefully that is the same thing, MSO, the multi-site orchestrator. Right. So this was very popular. This was very popular. This in fact is very popular. This actually ACI Epic infrastructure is very popular. In fact, in the data center infrastructure, you will see nowadays also, you will see the same like ACI Epic concept. They have like different versions of the ACI Epic like nowadays in the data center network. I think version 6, I believe 6 is, yeah, I think is the 6 point something is the latest one. Yes. So since like when they implemented this, ACI Epic concept in the data center, they noticed that their workload, like, it was like very easy to manage all those things from one centralized dashboard. You could see all the switches on there. You could see all the cables and everything. You can push the configurations. You can do like a lot of things from this ACI Epic, SDN solution that they built.
The policy
Endpoint group, EPG, and policy, like those concepts we have in the ACI Epic. So like it became very popular. Like this ACI Epic concept became very popular in the data center infrastructure. A lot of like companies, they started using it. So they thought, why don't we actually use the same for the enterprise network, because we cannot use this in the enterprise network. For this Epic to work properly, you need to have this ACI infrastructure where you need to have like some switches connected in a spine leaf type of topology, then and like top of the rack, end of the rack servers and all that thing. So this was like this concept was specifically for the DC infrastructure, because of the way those DC infrastructures are built. So they thought, why don't we use the same thing in the enterprise network? So what they did, they created an enterprise module for the same. They created this thing called Epic EM. These are two different products. Like Epic is a different product and Epic EM is a different product. So Epic is specifically for the data center network, and Epic EM they configured. They created this Epic EM software, hardware, whatever you say. This Epic EM, same thing, application policy infrastructure controller enterprise module. This was specifically created for the enterprise network. Like in your campus local area network, the same functionality that we were getting in the Epic, we will get in the Epic EM. However, this was specifically for the enterprise network. The problem with this was like this could not gain like a lot of popularity actually. This Epic EM controller actually could not gain like a lot of popularity. A few companies started deploying it. They might have noticed some advantages, some disadvantages. This actually could not gain like a lot of popularity. Other solutions were there as well, such as, for example, I'm not sure if you guys have heard of it, but if you have like, there was something called Prime Infrastructure, Cisco PI. There was one controller, one device referred to as Cisco Prime Infrastructure. It was very popular controller before DNA came into the market. In fact, Cisco used to sell these Prime Infrastructure controllers before the DNA Center controller actually. So this Epic EM like could not gain a lot of popularity. Other solutions were made, like such as, for example, Prime Infrastructure and everything, and they gain like at least a little bit of popularity. Then after when this I think like in after Cisco acquired Viptela in 17, 16, something like that, Then Viptela was a company that was providing the SD-WAN solution for a very long time. Like, then Cisco saw the market of the software-defined networking and they acquired Viptela, I guess in 16, 17, somewhere around there. And they pushed Cisco SD-WAN Viptela as the SD-WAN solution for wide area network. Before that, Cisco also had this thing called, for the WAN, they had this thing called I-WAN, intelligent WAN. It was also one solution before SD-WAN came into the market. So that was also one solution. They have a dedicated book regarding this I-WAN technology. Anyway, so then what happened then in around like 1718 when like 1928 approximately this SD-WAN gained a lot of popularity in around like 1920s. 2019 2020s, it gained like a lot of popularity. People are already using software defined WAN provided by different vendors, but suddenly in 2019-20 when this COVID hits, at that time everyone was working from home and everything, people were searching for the new technologies, companies were searching for the new technologies. So this SD-WAN gained a lot of popularity at that time actually, and right at that time they also launched a repurposed EPIC-EM. SD-WAN became like very popular in 2020-21. It gained a lot of popularity. Still today, like a lot of candidates are learning SD-WAN. A lot of companies are moving to the SD-WAN. I still remember in 2020-21, I had more batches of the SD-WAN than the CCNA CCNPs. Like that much popularity there was. Like suddenly everyone was talking about SD-WAN. And almost like all the companies were moving to the SD-WAN. Everyone was hyped that, okay, SD-WAN is going to eliminate the MPLS and so and so and so. But still, like DNS Center was nowhere in the picture. SD-Access was nowhere in the picture. Everyone was talking about WAN. When SD-WAN got stable a little bit, like when companies migrated to the SD-WAN, people learned SD-WAN. I still remember that there was a time when if you go for the SD-WAN interview, they will just ask you what is the controller, how to use the controller and all that. Just come in, join. Yeah, they will just ask you what are the controllers, like, how those function, what are the basic functions of the SD-WAN and everything, and then, okay, join and let's work. That was the level of interview at that time when, SD-WAN was just in the market. And then, like, in, I think, 21, 22, then they pushed this DNS Center concept into the network. So they repurposed. DNS Center is just actually repurposed EPIC-EM. Half of the thing in the DNS Center is the EPIC-EM. Like they more like repurposed, rebranded the EPIC-EM controller that they already created with the name of the DNS Center, which now is known as the Catalyst Center. DNS Center has been renamed again to the Catalyst Center. So EPIC-EM was there. When they repurposed the EPIC-EM, they created this controller called DNS Center. DNS Center is just EPIC-EM, actually EPIC-EM with assurance feature. EPIC-EM was the controller that they already created. They added some assurance, means more like monitoring, troubleshooting, and those features. And then they call this like DNS Center. And just like 2-3 months back, now just 2-3 months back, they renamed like all the SDN solutions. Cisco renamed this SD-WAN and this SD-Access solution to like Catalyst SD-WAN. So nowadays, like it's no longer Viptela SD-WAN, Cisco SD-WAN. It is just Cisco Catalyst SD-WAN. So they have renamed a few things in the SD-WAN as well. And this DNS Center also got renamed to the Catalyst Center nowadays. Right. So I think like in 2-3 months back, they renamed it, but now people have started noticing it, that they have renamed this to the Catalyst Center. So then like this more like was repurposed into the DNS Center, which again was renamed to the Catalyst Center. Nowadays we have Catalyst Center, which is again DNS Center, and DNS Center is in fact the EPIC-EM, which was inspired from the EPIC controller that we have in our data center infrastructure. So if we summarize like if you want to build an end-to-end SDN solution in our network, end-to-end SDN solution in our network, We have, let's say, for example, a data center. In the data center, we can still go for ACI Epic. To connect this data center to the branches, for example, as a WAN solution, we can go for SD-WAN. Like here, we can have SD-WAN. And we can have like SD-WAN routers, SD-WAN routers, SD-WAN routers. These SD-WAN routers can form these secure IPsec tunnels from one end to other end in more like an automated fashion. So this connectivity can be done with the help of the SD-WAN. Like WAN connectivity, we can do with the help of the SD-WAN. And then for the campus local area network, we can have SD-Access or SDA to manage the campus local area network device. So if you want to have like end-to-end SDN solution, you can go for like SD-WAN for the next gen wide area network. You can go for SD-Access for the campus area network, and you can go for Epic for the data center based on ACI. So our course focus is just going to be on the SD-Access. When you study SD-WAN, then SD-WAN will be there, and ACI Epic mostly you will cover in the data center infrastructure. So whenever you study about the data center, they have dedicated certification referred to as DCACI. So in this dedicated certification, you will notice the use case of the ACI infrastructure and the Epic controller that comes with it. So we are going to focus on this one. So modern day networks that we have can be deployed around three major SDN solutions. Remember that we are talking about Cisco. So three major SDN solutions offered by Cisco actually. So if you have Cisco devices, you can go for like SD-WAN. If you have Cisco devices, you can go for SD-Access. And if you have Cisco devices, you can go for this like ACI Epic concept. Other vendors are also there. Other vendors like such as Versa, VeloCloud. These are also other vendors that offer the SD-WAN solution. Similar to that, a few vendors you might also notice that offer the SD-Access solution. Still, like it has not gained a lot of popularity. And other infrastructure, other like companies might also refer similar solution based on this ACI data center. But from Cisco, since our content is Cisco specific, we have Cisco SD-WAN. Cisco offers two SD-WAN solution also. You should know. Cisco offers like two SD-WAN solution. One is offered by Meraki and one is offered by Viptela. Meraki is typically for small businesses, like where you just purchase a device, connect that device into your infrastructure, and that device can directly be managed from the cloud. No controllers need to be deployed. Like not a lot of things you need to do in case of Meraki based SD-WAN. But also you will not get like a lot of functions. You will get like most of the management from a centralized point, but you will not get like a lot of functions. So if you have like a medium or a large scale network, then the Viptela based SD-WAN like you should go for. So two SD-WAN solutions Cisco offers. One offers like Meraki based SD-WAN, one offers Viptela based SD-WAN. One SDA solution it offers, and one ACI Epic data center solution they actually offer. So three major SDN solutions are there, and they work together like end to end, something like that. So we can have in our campus network, we can have SD-Access. In the WAN, we can have like SD-WAN, and in the ACI data center, we can have the controller referred to as the Epic. So if we want, we can build an end-to-end SDN solution for our campus, for our enterprise network, if I say. So if you want to take full benefits of the software-defined networking, we have these three solutions. And also, if you go for, let me show you. If you go for like, let me open the demo again, that DCloud one. If you open this Cisco DCloud and you open the latest demo for the DNA center, let me show you. So again, a lot of versions are there for the DNA center software. 2.2.3 is the latest version, and I believe they stated that they will launch the version like DNA center version 6 and 7 directly like now. So from 2 to directly like 6 or something like that. So not sure are they going to skip the other versions or what, but let me quickly log in. So if I go to that DNA center demo that we had in the last class as well. So just logged into the DCloud. What they are planning actually to do in a longer term, as per my understanding, they will make this DNS center the centralized appliance for everything sooner or later. This DNS center will be able to interact with the ACI epic, and this DNS center will be able to interact with the SD-WAN vManage. Sooner or later, they will do that. In fact, if you notice the graphical user interface, you notice across all the Cisco devices, now they are making it exactly similar. That blue color theme and everything, you will notice that you go for a new, like for example, WLC, you go for a new ICE version 3, you go for a new SD-WAN, you go for a new SD-Access, any technology you talk about, they are trying to make like things like look similar, like at least from the user interface point of view. So if you open, like for example, the demo for like ICE, you will notice that it will have the similar kind of user interface as the DNS center offers. Like it will offer a different thing, but it will have similar kind of user interface, like same look it will give you. And sooner or later you will notice that they will actually make this DNS center as a centralized controller to manage like LAN and WAN appliances. Yeah, so compatibility you have to check. Like if you have, we'll talk about the compatibility. So a point is that if you have a compatible hardware at your infrastructure or at your home, that can be managed by the DNS center or the other, like for example, providers, other services such as Meraki or so. Not everything is compatible with the DNS center. That is one of the biggest challenge at the moment that we have. DNS center.
Some of the models like the 4500 and 3850, I think they are capable.
So like not everything is compatible. So what things are compatible? They have given a matrix for the same. You can always refer to the matrix to find out like what devices are compatible and can you migrate to the SD-Access right away or not. Otherwise, you need to purchase new devices for the same. Basically, it's about a hardware chip that is there. We'll talk about that later on. But what I'm trying to say is that you open any like IEC, you open WLC, you open anything, you will see similar kind of like user interface nowadays. Similar kind of like this, then this, then this. Similar kind of interface you will see like on all these like appliances. So you notice here, if you go to the DNS center and if you go to, let's say, for example, like tools or just go to the system settings. If you go to the DNS center, you go to the system, you go to the settings, you notice that this DNS center can actually be integrated with a lot of external services, For example, Umbrella. You can integrate like Cisco Umbrella account on here. You can integrate like authentication and policy server, which means like we can integrate ICE or other radius servers that are available. We can integrate here, right here. When we can integrate our SD-WAN controller, vManage with the DNS center. We can integrate like IPAM, IP address manager, info blocks, and the other like blue coat. Those like you can integrate as well. Stealth Watch, Talos, the security team, Cisco security is provided by this Cisco Talos, right? CMX server, Cisco Spaces is again for the DNS center, right? So you will notice sooner or later DNA cloud. So remember that nowadays Cisco DNS center can also be deployed on the cloud. So they have a scaled down version of the DNS center that you can deploy on the cloud and you can use directly from the cloud. You don't need to purchase any hardware or things for the same. We'll talk about that later. So you can see here that if you go to like these external services, they are continuously adding like new external services that can integrate with this DNS center, right? So for example, WebEx and other things like ThousandEye is more like a monitoring tool that they have. Okay, so the point is that sooner or later you will notice, since the vManage can already be integrated, you can see the only thing that is left is to integrate somehow the ACI epic. That is the only thing that is left. This DNS center can already communicate with the vManage. This was not available in the older version. In the older version, you did not have this vManage integration with the DNS center, but now we do have the vManage integration with the DNS center. And one more thing, you see here, you go to the policy, for example, just to give you the idea, you go to the policy, you go to this group based access control. Here we have the option to create like the policies for our enterprise network based on those things called scalable groups, which is part of like ICE and everything. We'll talk about that. One thing you should see here, if I create a scalable group, one thing I would like to show you here, that if you create a scalable group is basically like we can create a scalable group to perform this thing called micro segmentation. Such as, for example, in our corporate network, we have HR department, finance department, admin department. So we can separate, or we can divide this. We can identify the HR department with a different tag, HR admin department with a different tag, finance department with a different tag. These logical groups are what we refer to as the scalable groups. So I can create a scalable group here, and right here you will notice that not sure here, but they give an option here that says like propagate to ACI. There was one option here on the bottom. That option says like propagate to ACI. So we can create a scalable group and we can propagate that scalable group to the ACI data center as well. So somehow, like sooner or later, they will integrate the ACI, full-fledged ACI capabilities with the DNS center, so that DNS center becomes the centralized point from where you can, manage all these things. vManage will still remain the controller for the SD-WAN. ACI Epic will still remain the controller for the data center network. DNS center will just be able to communicate with those things, and you might be able to configure like all these things from here itself, from the DNS center itself. More like from the so for example, like you have an ACI data center, you have like vManage, you have like all those like WAN devices. You can do all the monitoring, everything. You might be able to do all the monitoring and everything from here sooner or later. At the moment, we do have the vManage integration, but at the moment, like I don't think like they have this ACI Epic like integration available at the moment. A few things you can do about the Epic, but not all the things you can do on here about the Epic. So, but as per their long-term goal, they will make this DNS center sooner or later centralized controller like for like everything.
Centralized policy, maybe they can introduce.
So you can create the policy on here. That policy can be pushed to the Epic controller in the. So they might do it. They might do it like sooner or later. But at the moment, only thing that you will notice this DNS center being used is to manage the campus local area network. And what we can do, we can integrate our vManage with the DNS center, so that like some degree of control we will get on the WAN devices that we have placed in our infrastructure as well. So this DNS center at the moment is SDN solution for campus local area network for both like LAN and somewhat the WAN. So we will have like SD-WAN deployed. We will have our SD-WAN controllers deployed, and we will integrate that SD-WAN with the SD-Access. So we will have full-fledged SDN solution for our campus network. So the topology will become something like that. For example, here we have a few, let's say, for example, access layer devices. Then we have a few distribution layer devices. We can have core layer switches, or I would just go for the router. These are like routers, core routers, so directly. And then we can connect to the external network respectively. So something like that. So what we can do, we can use like our DNS center to manage the campus local area network here. And these devices, these are not normal. These are not like traditional WAN routers. These are like SD-WAN routers, like V-Edge or C-Edge devices, which is a term in SD-WAN. So these are like software-defined SD-WAN routers, like VS devices or CS devices. So these are managed by the vManage. These devices are being managed by the vManage, and these devices, these switches and everything, these are being managed by the DNS center. And DNS center can communicate with the vManage. So some degree of control you will have on these managed devices as well. So for the campus local area network, we can have like SDA solution for LAN and SD-WAN solution for the wide area network WAN devices, and overall it is going to give us the SDN solution for our campus network. It's kind of like the same like Epic DC, where we can do some management from the other devices as well. So how this is going to solve those challenges that we have talked about? So Cisco SDA, we'll talk about that, but one controller that we use in our Cisco SDA solution is referred to this DNS center. So first let's see all those challenges that we were talking about, how this DNS center is going to solve all those challenges. Let's talk a little bit about all those challenges that this DNS center is going to solve. So one challenge that we had in our traditional network, that was like the challenges regarding like management of each and every device one by one. Here, what we can do in our Cisco DNS center, once the DNS center is able to reach to all the devices in the network, we can do all the management, everything we can do from here itself. We can monitor, we can go to, like, for example, assurance dashboard, we can go to the assurance workflow, and we can manage all the devices from this centralized point. Like if you want to do management, you want to just do monitoring, you can go for the assurance tab, and if you want to configure or provision something, you can go to the provision tab. So click on, for example, like provision workflow, and here you can click on, let's say, network devices, you can click on inventory, and here you will get a list of all the devices that you have installed that is reachable to the DNS center. All the devices, all the routers, all the switches, all the wireless controller, all the access points, all the different sensors that you might have deployed. So for example, you want to see how many switches are there. So you click on just this like switches, just click on this switches, and here is a list of all the switches that you have deployed in different geographical location. All the switches that you have deployed in different geographical location, you can manage it, we can check it and manage it from here. Every information, you can see that these are Catalyst 93, 9500 series switches that they have deployed. And the point is that you can click on any of these. You can click on like any of these. For example, like you can just go here, click on any of the device, such as, for example, let's click on this device. You click on this device, it is going to give you a brief information about the same, like what kind of device it is, what image version it is running, where exactly that device is placed, right? Did we provision this device? Provision basically means like, did we push any configuration and the configuration push was successful or not? What kind of device it is, basically what role it has been set to. We can see those things from here. And if you want to get more information, just click on this view 360. This is what we call device 360. So we can get the 360 information, like complete information about the device right from here. Just click on this, it will open a new tab, and here you will get in detail complete information about that particular device. About that particular device, you will get complete information right from here. Right, let's see here. This is what we refer to as device 360. This device 360 is going to give you a 360, means complete like information about that particular device, which you might have noticed on these monitoring softwares, like SNMP monitoring softwares your company might use. From there we can manage those devices. That thing can now be done from the DNS center itself as well. And in fact, we can run the commands right from here as well. Right from here, you can see like these are, for example, the list of commands that are supported at the moment. And like, for example, these are like show commands, like these are like show, for example, these are the show commands that are available. So for example, show IP into brief. Okay, this is not available. Show users, for example, let's see. No, it's not. Sure. So not all the commands are supported, but we can run the commands. We can take the SSH access later on, but we can run these possible commands, like for example on here. So variety of commands, like what are commands that are supported? So use the keyword man. and it will show you like what commands are actually supported. For example, you can do ping, trace, you can use a few show commands, like you can use the standby keyword. These are a few commands, ping and trace and everything. So these are like a few commands that are supported right from here. Some verification commands you can execute, you can run right from here itself. So just click on this and just click on run commands, and it will just open this kind of tab, command runner, and from there you can run some basic verification commands right from here. And if you want to get more detailed information, just click on device 360, and it is going to give you a whole, like the complete idea about that device right from here itself. Right, we might not have access to that device 360 part, but we can get the information right from here. Right, so we will see if it loads, then I will show you. So we can get, like, we can get the entire information about the device from here. So we don't need to log into each and every device one by one, because we have a centralized dashboard from where we can see, we can manage all the devices right from this centralized dashboard itself. Right, so you can just click on the device, you can manage it from here, you can check the 360 information, that is like complete information about the device right from the main dashboard. And if you want to configure a few things, such as, for example, we have updated our AAA server and we want to push that AAA server information to everywhere. All you need to do is to just go on to, let's say, for example, provision, inventory, just select the devices, just select all the devices where you want to push a AAA, for example, server information, DHCP server information, NTP server information, whatever. Then go on to the action, provision, and you can provision the device. Provision basically means like we are going to push certain configurations onto the devices. So provisioning basically means like we can do some level of configuration onto the devices as well. Right from here, right from this box itself, right from this tab itself, we can actually, for example, reboot the device, we can delete the device, we can like export the inventory information, we can like upgrade the software image of that particular device. Right from here, it is possible to upgrade the software images. We can add the device to the site, we can do the configuration, we can configure the WLC HA from the DNS center itself. We can configure things about the telemetry. We can mark the device for the replacement. Like, for example, a device needs to be replaced, we can mark that device for the replacement, and then like we can replace that device with some other device and send this device for the replacement part. So like a lot of options are here. A lot of options are here that we can go for. We can run the commands and everything. So a lot of options are available actually here. Right. So the point remains the same, that we don't need to log into each and every device like one by one. We can do the management right from the main dashboard that is provided within the scope of the DNAC center. So management becomes easy. Configuration becomes easy. Again, not everything you will be able to configure, not at least in this DNAC center. Like a few things you might still, if you want to configure, you might still need to log into the device and do the configuration, but most of the things from the campus LAN point of view, we can configure from here right away. So we don't need to log in on the devices on box by box basis. We can just do the configurations, provisioning, monitoring, and everything right from the main controller dashboard right here. The second challenge was the security related challenge. We used to configure things such as ACL, VLANs, and all those things. In the DNS center, what we can do, we can integrate this thing called ICE, Identity Services Engine. We'll talk about that practically. But what we can do, we can integrate here ICE. ICE stands for Identity Services Engine. ICE is more like, ICE is going to act as the policy server. ICE is going to act as a policy plane in our software defined access. That means once the ICE integration is done, once we have integrated ICE or any other AAA server with our DNS center, all we need to do is to go to the DNS center policy tab. Right from here, we can configure the policies for our campus network. Such as, for example, we have HR users, we have finance users. I want like finance user should not be able to communicate with the HR user. Very easily it is possible. No need to worry about any ACLs or so. What we can do, we can configure a policy in such a way that when any user connects itself to port number FA0x1, it will supply its user ID and password. Based on its user ID and password, it will become part of the finance group. It will be allocated a tag of finance, and then it will not be able to communicate with the HR. We can create all those things right from this policy dashboard. So this is what we refer to as right here, group based access control. We have IP based access control, ACLs and everything. We do have. If you want, we can configure IP based ACLs. If you want, you can configure traditional ACLs as well. But what we want to do, we want to configure the policies based on the group of the user, such as HR should not be able to communicate with finance or so. So that can be done right from the policy group based access control. Click on this. Click on this. Here what we can do, we can go to the security group, also referred to as scalable groups in terms of security. So here we can create our group of users, such as you can see, lights, such as you can see, like production users, production servers. We can create the group of users. We can create, like here, if you notice, total 27 groups are created here. This is a demo. So here they have created approximately 27 number of groups, and I can now go to the policy tab, and right here I can control just from this matrix. Similar matrix we get in the ICE as well. So from here I can control, for example, that doctors or employees, I can control that employees cannot communicate with the lights. Done. You can just configure right here. You can see employee, and you can see at the top you can see lights. That means employees will not have any access to the ICE. Employees, for example, cannot communicate with the guest. So just from your matrix, just come to this point here, employees and guests. You can see, click on this, change contract, and what do you want to do? I want to deny everything. So I will just say deny IP. Deny IP means deny everything, and done. Save. That means employees cannot communicate with the guests. Maybe I want to have limited control. Once you are done creating all these things, just click on deploy now. So it is going to push this policy to the identity services engine. So we don't need to log into the ICE. Once the ICE integration is done, our DNA center can become the front end from where we can do the configurations. We can create the scalable group just like we do in the ICE. We can create the policies just like we do in the ICE. So we don't need to log into the ICE. We can, if you want, like we don't have like here the option to configure like those authentication and authorization rules that we have in ICE. That thing still is needed to be done on the ICE. But for example, creating the scalable groups, policies and everything, we can simply do it from here. In fact, we can create our own custom access contract. Custom access contract basically means I can create a custom access contract that says I will only allow TFTP or FTP. I will only allow Telnet and SSH. I can create my own custom contract. I can create my own custom rules for communication, and then I can use those rules right here in the policy tab, such as, for example, doctors with, let's say, for example, employees, doctors and financial, or doctor with guests, enable the policy, and I'm going to say like our custom contract such as deny TFTP only. That means everything else is allowed, but TFTP will not work. Or only HTTP is allowed, and rest everything is going to be blocked. We can create our own custom contract, custom rules, and we can use those rules on here as well. So security, in enforcing the security becomes easy. And not only this, the same policy will be applied for both wired user and the wireless user. So it doesn't matter how the user is getting connected. If user gets connected to the network, if the user is connecting itself to the network, authentication is happening. User is getting authenticated by its username and password. As a result, the user is placed in the HR group, and all the HR policies are getting applied on here. Now, it doesn't matter if the user has connected itself with the wireless technology. Even if the user gets connected itself like to the network with the wireless technology, authentication will take place. User will supply its username and password. That username password will be checked by the authentication server, such as, for example, AAA, ICE. Once the user gets authenticated, it will be configured in HR group again, and same policies will be applied. So we don't need to configure two different policies for the wired and wireless users. So security, enforcing the security in the network for the wired and wireless user is going to be comparatively easy when it comes to like this DNS Center appliance. Third was, there was something called deployment related challenges. So for example, we need to deploy a new device and we need to configure a whole lot of things on there. What we can do within the scope of the DNS Center, we have this concept called template editor, which is now renamed as template hub. So what I can do, let's say I have configured 30-40 devices in the network, and similar set of configuration I need to do on more 30-40 devices. So what I can do, I can create templates. I can create variety of templates for like, those new devices, and the onboarding template, day end template. We can create different onboarding template. Basically means when the device is getting onboarded, then those configurations will be pushed automatically. And then day end template basically means that once the device gets onboarded, then after certain configuration is going to be pushed. So with the help of template, it becomes easy to actually push the configurations on n number of devices by marking some fields as fixed fields and some fields as variable. So what we can do, we can go to any device, we can do show run, we can copy all the configuration, paste it into the template, and we can mark certain things as variable. So that when we push the configuration, those things will be asked on per device basis. Certain things are going to be fixed, certain things are going to be variable. In fact, we can create very complex templates as well using language such as Velocity or Jinja. If you have the knowledge of the languages, then you can create like a very complex templates, inherited templates. Like this template is going to be called in another template. So inheritance is also supported. A lot of concepts are supported regarding the templates. And forget about that. Devices can be automatically onboarded with the help of this process called PNP. We can just, for example, purchase a complete new device. I can connect that completely new device onto the network. The device can automatically get onboarded with the help of process called PNP, plug and play. Such as all the devices that support the PNP function can be automatically onboarded into the network in a complete automated fashion. And while getting onboarded, I can push the configurations right from the template. So I don't actually need to do anything onto the device. This we will see practically. We will see PNP process practically. We will see how can we push the configurations while the device is getting onboarded practically. We will see that. But the point remains the same, that we can in fact deploy the device in our infrastructure very easily. Just in a few clicks, we can do that. All we need to do is to tell the branch engineer that this is one new device that you got. You have to just unbox that device, and you have to connect that device to the power supply cables and everything. Connect it to the network and just leave it. Rest will be done in an automated fashion.
In fact, you can migrate the old device as well. The old configuration will be wiped out and the new.
Migration, for migration, we have tools as well. We have migration tools as well. So we can, if you want, we can retain the configurations, or we can completely wipe that configuration as well. So we do have some tools. We'll talk about that as well. But we do have tools to migrate from the legacy to the software-defined networking as well. In fact, for example, PNP is one process. We do have this concept called, in our DNS Center, we have this concept called right here. This concept called, go to the provision, and here is this concept called LAN automation. This feature, that remember that in last class we talked about, we had the discussion that in order for the DNS center to work properly, the DNS center must be reachable to all the devices. Like if the devices are not reachable to the DNS center, then how the DNS center is going to manage all these devices? So the very basic thing is the reachability. Reachability has to be there from the devices to the DNS center. We have just deployed one of the device. We have configured, you don't need to configure all the devices. No, you don't need to do that. You just configure one device, make it reachable to the DNS center, do all the configurations, everything necessary from the DNS center, and then start this process called LAN automation. This LAN automation process can automatically discover all these devices. It can automatically configure the IP address on these devices. It can automatically configure the IP address, default gateway, routing, user ID, password, everything it will configure automatically. It will basically build this LAN automation process is to build the LAN network in a complete automated fashion. Basically, you don't even need to like configure any of these devices. Just one device you need to configure, make it reachable to the DNAC, and rest will be done in a complete automated fashion. That level of configurations can be pushed from the DNS center to there. We do need to, configure a few things on here for this process to work, but we don't need to set up all these devices like one by one, doing all the configuration of IP addressing, username, password, SNMP, then routing protocol. So you don't need to do anything. LAN automation is a process that is going to use the same PNP, plug and play services, to automatically onboard the device and build the LAN network in a complete automated fashion. Don't even need to do anything. Sooner or later, you will notice that there are indeed a lot of advantages of using the DNS center in the production environment. A few challenges are still there. Like compatibility is one of the challenge. They recommend using ISIS protocol, and not everyone knows about ISIS. That is one challenge. Not everyone knows about Lisp. Not everyone knows about VXLAN. So a few challenges are there, but other than that, you will notice that a lot of advantages you get from this DNS center. So deployment related challenges can be resolved somewhat with the help of this DNS center. And right here, finally, this that companies spend a lot of time in troubleshooting the network. They spend a lot of resources in troubleshoot. Here, you go to the DNS center, you go to this assurance dashboard. Go to the assurance dashboard. In the assurance dashboard, we can see this thing called issues and event. So all these P1, P2 issues that you get, you will get on here, just like a monitoring tool. Just like in a monitoring tool, you get all these like P1, P2 events that have issues that have occurred. You just click on this right here. You can see variety of open issues, resolved issues, or the issues that you have choose to ignore. So open basically means that these are issues currently being faced in the network somewhere. Resolved basically means the issues that you have resolved and marked as resolved. Ignored basically means the issues that you have ignored. So issues and events we can check. Events basically means what events are happening in the background. Like what events have occurred at a particular site, you can check the events. All these variety of events that have occurred onto the devices, we'll talk about that in assurance tab. Just get the idea that we can check variety of events that have occurred right from this dashboard, and we can see all the open issues that we have in our network right from this dashboard as well. For example, there are total 25 open issues, out of which 4 P1 issues are there, 4 P2 issues are there, P3, P4, like we can mark the priority and everything. So for example, at somewhere it is being reported layer 2 loops has been detected. So layer 2 loop symptoms are there in some of the site. So that is like, for example, one P1 issue that we are facing at certain location. So we can get the idea, we can get to know about DNS center, since it can reach out to all those switches. DNS center can take a look at the logs, like SNMP messages. It can take a look at those syslogs, telemetry information. DNS Center has the access to all those data, and DNS Center, based on that data, can observe that some challenges are there in the network. So, for example, the DNS Center has detected that some loops are there. Anyone else is facing any voice issue? Am I audible to others? Just confirm once. Okay.
Yes, we can hear you.
Just a minute. Okay. Now, see, not only DNS Center can report the issue. It's not only that it can only report the issue, it can also suggest the actions that you should take to resolve these issues, such as it uses this AI machine learning capabilities. And what you can do, you can just click on, for example, let's say, for example, this issue has been reported. Just click on this issue. Just click on this issue. So here, the DNS Center has noticed that in this location, a host is flapping in VLAN 1. That means some looping problem is there in the VLAN 1. Just click on this issue, click on this, and just scroll down a little bit. Scroll down. Here, right here, we have this option called root cause analysis. Click on this, run machine reasoning. As soon as you do that, the DNS Center in backend, it is going to run these some algorithms. It is going to run these AI machine. It is going to use its AI machine learning capabilities, and it will not only give you that this is the problem that we are facing, but it will also give you that a loop has been detected on VLAN 31. Why the loop has been it is telling you that looping has been detected on the VLAN 31. It came to the conclusion after running this machine reasoning and all. It came to the conclusion that the loop has been detected on the VLAN 31 in that network. And if you scroll down right here, it says suggested action that enable VLAN 1 STP on these devices. So looks like VLAN 31 STP is not running. Looks like the spanning tree protocol is not running on some devices for VLAN 31. That is why the loop in VLAN 31 has occurred, which is giving some challenges. So not only it can detect the issues, but it can also run this root cause analysis and can give you suggested action based on the same. View all the relevant activities. It will give you like all the things that you can do to resolve that particular problem. So when it comes to like troubleshooting, DNS Center gives us this dedicated dashboard to us from where we can check variety of issues in the network, and we can actually find out the errors, or try to correct the errors based on this. So like you will notice that a lot of challenges that we were facing in our traditional network can be resolved with the help of this DNS Center device. Again, a few challenges are still there, such as, for example, it is a hardware-based device. You need to have a compatible hardware for the same, such as they recommend running like things such as ISIS. You need to have the understanding of the VXLAN, Lisp, and all that. So certain challenges are obviously there, but other than that, you will notice it will come to be like this device, this DNS Center appliance. You can manage all the devices, all the sites from one centralized point. We can configure the policies. We can manage the networks. We can configure the network profiles. We can do the software image upgrades and everything. We can do like almost everything that we can do on the physical devices right from this DNS Center dashboard. We can get the complete information about the device. We can, from this assurance tool, from these variety of assurance tools, we can check the variety of issues. We can do a lot of things from this DNS Center appliance. So all those challenges that we had talked about, like all those network operation related challenges, all those security related challenges, I'm not saying that everything can be fixed, but like most of the problems you are facing in a traditional network can be fixed by use of the software-defined networking, and that's why companies are more like inclined to use these solutions in their production environment. So DNAC is going to be used like for your uh, SDA solution, for your campus local area network solution. Same thing you can go for SD-WAN. So when you study SD-WAN, you will notice the use cases of the SD-WAN. Remember that SD-WAN is there to manage all these WAN edge devices from one point. SD-WAN is not able to manage the LAN devices. SD-WAN is able to manage these WAN edge devices. SD-Access is able to manage the campus local area network for both wired and wireless infrastructure. A lot of wireless options are there. A lot of wireless options are there. You can go to the design, you can go to, for example, settings, and you can configure a lot of things about the wireless network right from here. Such as, for example, you can configure SSIDs, you can configure like IP address pools, we can configure whole a lot authentication and everything, a lot of things. A lot of things we can configure regarding the wireless on here. It is basically for both wired and wireless network. We can nowadays also configure profile for security. Like for example, certain level of firewalls are also supported in here. So not only routers, switches, WLC access point, firewalls are also supported with the DNS center. They can also, DNS center can also push certain level of configurations onto the firewall.
Yeah, that Cisco umbrella is there.
Umbrella is there. Yes, URL filtering is ICE, complete ICE is there. So regarding dedicated firewalls, we do have option to create the policies for the or the profiles or the configuration sets for the firewalls. So just configure one firewall, pull all the configuration, paste it in the DNS center, mark the fields as variable, and push the configurations on rest of the firewalls. So a lot of functionalities like they are adding day by day. So nowadays we can also manage like our certain degree at certain level we can manage like firewalls and the wireless network as well. Again, not everything is supported. So it's not like you will get exact same experience as you get on the CLI of the device. It's not exactly the same. So here and there you will notice a few things are not supported. You cannot do a few things from the DNS center that you are able to do from the CLI. Here and there you will notice that, but no problem. You do the configurations from the CLI and sync those configuration onto the DNS center. It will work fine. Whatever configuration, it's not like SD-WAN. It is not like SD-WAN where if a device you have attached with a template, it can only be managed by the template. It's not like that. Here what we can do, we can configure the device via DNS center and we can configure the device locally as well. And then we can sync the configurations from the device to the DNS center. DNS center is going to pull all that configuration and will be able to show you what configurations you have done onto those devices. That is also possible. So a lot of benefits you will notice, of using this DNS center tool. Cost, in compatibility, infrastructure like migration. These are some challenges still, but other than that, it is a very good solution for your campus network. And within the scope of the DNS center, we have one thing referred to as the SD-Access. Within the scope of the, we have other things as well, but we have one thing specifically for our campus local area network. That is what we refer to as the SD-Access, which is our actually course focus. This is what we are going to talk about as a part of our content right here. So SDA is just one solution offered by Cisco, offered by the DNS center. SDA is just one of the solution offered by the DNS center. SDA is building our campus network based on intent, like what engineer wants to configure, and the software will configure that thing in your campus area network. Campus could be anything: college campus, enterprise campus, any campus. So these are the advantages, I would say, of using Cisco DNS Center, and how this DNS Center is going to solve, if not all, most of the challenges that you are facing in your enterprise network. Let me know if you guys have any Q&As, any questions, anyone. Okay. You can go for both. You can migrate your existing infrastructure into the SDA, or you can deploy it completely fresh. Both the things are possible, but the only thing that that you need to know, if the devices that you have in your infrastructure, are they compatible with the DNS center solution or not? Uh-huh. No, no. You can sync the configurations. The configuration will remain as it is. Basically, what how the DNS center, how the SD-Access operates is a little bit different. SD-Access operates by setting certain rules onto the devices, and so based on what rules you are setting onto the devices, configurations are going to be pushed. Existing configurations might remain as it is, or you can choose to wipe it completely as well. If you are going to use things such as, for example, LAN automation and those things, or PNP, for example, then you need to wipe the complete configuration. Otherwise, your existing configuration can remain there as it is.
We need first of all fabric
To create the fabric. So to create the fabric, actually, the DNS center is going to push certain configurations on there.
Yeah.
So that configuration must not conflict with your existing configuration. For example, loopback 0 it uses for its operation.
Yeah.
So loopback 0 must not be there. Must not be, or if it is there, you should use that loopback 0 to discover the device in the DNS center and push the configurations and everything. For example, when we are using PNP, VLAN 1 must not have any IP address on anywhere. So certain limitations are there. So point is that your existing configuration must not overlap with any configuration that will push by the DNS center. Rest will work fine. Yes, Vijay. Yeah. Let me know questions if you have.
Yeah, Ali, as a for LAN automation, we have to configure one switch first. Am I right?
Yes. At least one device you need to configure. This is one device that you need to configure, and this device must be reachable from the DNS center. This is what we are going to refer to as the seed device. And from there, the rest of the network can be discovered and configured in a complete automated fashion.
But where we will define the IP details?
Sorry?
IP details where we
Yeah.
where
Everything you will configure on the DNS center. You will configure that, okay, what IPs we need to give, what user ID passwords and everything. We will, once we start the LAN automation, it will ask us a few things. Those things we need to configure, and then the DNS center is going to configure those things onto the devices. We will give our intent to the DNS center that we want to configure this IP, this user ID password and all those things for the devices, and then the DNS is going to push that thing on there. So we do need to configure a few things on there. But we don't need to touch these devices actually. These devices that we want to onboard, we do not need to touch these devices.
So which protocol they're using to communicate from DNA to the devices?
SNMP, as simple as things such as SNMP, APIs, those things, but as simple as SNMP can be used for this purpose.
And we have an option to use API or netconf. So is there give us an option? Which one?
Yeah, we have like netconf yang, for example, to manage the WLCs. Wireless LAN controller, it can use netconf yang, that option is also there.
Okay.
But majorly, you will notice the use of SNMP protocol. We will need to configure like SNMP credentials and everything. And then other techniques such as, for example, like netconf, restconf, APIs, those things can be used to push the configurations, retrieve the information as well.
So meaning you will configure SNMP first on the device?
Yes.
In order to communicate? Got it.
Yes. SNMP, SSH. SSH protocol it will also use. Like it will log into the device using SSH, then push all the configuration and then retrieve the information with the help of the SNMP.
Ali, I have another question. If
Oh yeah.
I use the LAN automation, then that time is need to the template or template is for
You can
different
at
purpose.
the time, yeah, it is completely your choice. Like at the time of, like, for example, LAN automation, when a new device is being discovered and you want to push certain configuration, yes, definitely you can create templates. Like you can create the templates onto the DNS center, and you
Yes.
can tell the DNS center that when the device is getting onboarded, push this configuration there. So yeah, that is possible. We will do that practically.
Okay.
Yeah.
Both are same, but this is the different way. Am I
Uh,
right?
both are same. Like I don't get it. Like what two things are same?
This LAN automation, actually we want to the configure the switches,
Okay.
but one by the the LAN automation, another by the template.
No. The point is that, see, the thing is that LAN automation is actually used to build the LAN network of the campus, area network in an automated fashion. At that point, I can tell when these new devices are being discovered with the help of this LAN automation process, they are being configured with the IP address and all those things. I can tell our DNS center, I can give the instructions to the DNS center, then that push these configurations as well. I will configure the templates in our DNS center to tell it that, okay, these are the configurations that we need to push on the devices while the devices are getting onboarded with the help of the process called LAN automation. We can also do that later on as well. Like if you don't want to push any configuration right at the point of the onboarding, later on, like once the devices get onboarded, then also we can use the concept of template to push the configurations later on. So with the help of templates, we can push the configurations at the time of device onboarding or later on as well. LAN automation is just to build the LAN infrastructure in an automated fashion.
Okay, got your point. That means just suppose there's anything change in my network, like the SNMP version or other things, that
Hmm.
time we can use for the
You can use the
template.
templates. Yeah, you can use the templates later on to push all the configurations, all the necessary configurations on n number of devices at once.
Okay, thank you.
Yeah. So, what is Cisco SDA again? Cisco SDA is a solution within the DNS center. So one part of the DNS center, uh, one thing that the Cisco DNS center or Catalyst center offers is called the SDA solution. It is built on the intent-based networking, where the engineer defines its intent onto the DNS center, and the DNS center is going to push that intent onto the network. It provides visibility-based, automated, end-to-end segmentation to separate the users, devices, applications, application traffic without redesigning the underlying physical network. It just means like our underlay network will remain as it is, whatever we have configured, traditional routing, switching, whatever you have done. Your underlying infrastructure will remain as it is. Then what this DNS center can do, this DNS center can create a logical network on the top of this underlay network, which is what we refer to as the overlay network, also referred to as the SDA fabric. In that SDA fabric, we can place the users based on certain group, such as HR, such as finance, such as admin, and then we can create the policies based on the same. So we don't need to change our underlying infrastructure. Our underlying infrastructure will remain as it is. And for example, we can separate the HR users from the finance user just based on things such as tags, scalable group tags. And then we can create the policy that the HR users cannot communicate or can communicate with the finance user. We can also create this thing called VN. VN stands for virtual network. A VN is basically VRF. We can create VRF to separate our application traffic with like the IoT devices with like the corporate users. We can create three different VRF referred to as VN in terms of SDA. And those VRF or VMs are going to separate our corporate users with the applications and with the IoT, with the other devices that we have in our infrastructure. And the best part is we do not need to change our underlying infrastructure to achieve any of this thing. We don't need
So
to.
the VN, Sorry to interrupt you. So the VN is a new term for VRF, or just here they call
No.
it VN?
VN is what we use in the SDA terms,
Okay.
the name for the
Okay.
VRF. Otherwise, like in traditionally, we call it like VRF. The same thing is in the SD-WAN referred to as the VPN.
Okay. So this solution is for underlay and overlay, or just overlay?
This uses a concept of underlay and overlay. Underlay means
Okay.
like what underlay is going to be, underlay will be responsible to make the basic purpose of the
Basic
underlay.
connectivity.
Yeah. The basic responsibility of the underlay network will be to make the reachability from the devices to the controllers, such as, for example, the DNA center. And then on the top of that underlay, we can create the overlay network based on our requirement, and we can redirect the traffic from one point to the point without changing our underlying infrastructure. So yes, SDA is going to use the concept of underlay and overlay. Underlay will provide the services to the overlay. What services? Reachability, for example.
Got it. Thank you.
Cisco SD automates the user access policy, so the organizations can make sure that the right policies are established for any user, any device, with any application across the network. This is done by applying unified access policies for LAN and wireless LAN. Right here, already we have talked about that. Right here, we can create three types of policy. We can create the policies for the security. We can create the quality of service policies, and we can create the policy for copying the traffic from one point to the point. Three policies are there. One policy is for security, like securing our network based on like IP ACLs, URL based ACLs, scalable group ACLs, like group based access control. We can create the policies for security. Then we can create the policy for quality of service. For example, our devices are connected to two service providers, and we want to enable some quality of service for certain applications. So we can create application quality of service policies as well. Then we can create the policy for copying the traffic, span, switch port analyzer. We can create the policy for copying the traffic from one point to the other point. Anyway, what we'll talk about that in the policy section. Anyway, whatever type of policy you are creating, the policy is going to be applied for the wireless and the wired users at the same time. You do not need to create a separate policy for the wired user and a separate policy for the wireless user. No matter if the user gets connected to the network with the help of wired technology or the wireless technology, same unified policy, same policy can be applied onto the devices for the users. Remember, ICE, Identity Services Engine, will be the policy plane in our SDA network. ICE will be required, or if you don't have ICE, then any AAA server will be required to enforce the policy in the network. Remember that we have Radius and TACACS, two protocols in security, in authentication authorization concept. Now, one of these Radius and TACACS, one is like Cisco proprietary, one is like open. So if you are going to use ICE, you might get both of them. But if you are going to use like a generic AAA server, you might get only one of them. So based on, are you going to perform the authentication authorization for the users, or are you going to perform authentication authorization for the devices? So device for the devices, we want to perform the authentication authorization, or for the users, we want to perform the authentication authorization. Based on that, you are going to use either Radius or TACACS. So based on what solution you are using, a generic AAA server or an ICE, you will get either Radius, TACACS, or maybe both of them. But anyway, let's not go in that detail of the policy section at the moment, because we will discuss this later on in detail. Just understand here at the moment that we can create one policy from our DNA center, and that policy can be applied for LAN and wireless local area network in a unified way. We don't need to configure two different policies for wired and wireless network. To build an SDA solution, what things we need? We need a controller and controller based architecture. We need a controller and a controller based architecture. Within the scope of the Cisco software defined access, what we need what components we need first of all a controller and controller based architecture, the network architecture that is built to support the controller. Controller based architecture is going to use devices compatible with the controllers. so that the controller can push all the necessary configurations and everything onto those devices. As you know, controller in Cisco SDA is going to be the DNA center, also referred to as the catalyst center. This controller based architecture is going to use variety of switches, variety of routers in the underlying infrastructure, protocols such as, for example, ISIS, protocols such as, for example, Lisp, VXLAN, all those things. So we will build a network, an architecture for our controllers, and the controller that we are going to use is going to be the DNA. Policy enforcement engine. What is this? This is identity services engine. Within the scope of Cisco SDA, we are going to use Cisco ICE identity services engine as the policy enforcement engine. Network fabric. It is like underlay and overlay. Underlay is the underlying. Fabric generally means overlay. Generally, like in most of the situations when we hear the SDA fabric, they are typically talking about the overlay network. But network fabric like overlay will not work until the underlay is running okay. So underlay has to be there. Underlay must be configured properly, and then on the top of the underlay will be responsible to provide the reachability from the device to device and the device to the DNA center, devices to the controller, devices to the ICE. So once the reachability is there from the underlay network, then only the overlay network can function. So underlay and overlay, both of the things will be required to create a complete network architecture or network fabric. In overlay, we will use two protocols, Lisp and VXLAN. To create the SDA overlay network, we use protocol Lisp, we use a protocol VXLAN. We will talk in very detail about these two protocols. Not in very detail, but in as much detail as per our content. Lisp is very heavily used in internet routing architecture. VXLAN is very heavily used in data centers. So we possibly cannot cover like everything about the Lisp and VXLAN. We will cover only those things that are useful from our SDA content point of view. Yes, that is true here as well. It's not like you need to know everything about the ISIS. For example, it's not like you need to know everything about the Lisp or VXLAN, because you will notice when we go through the configurations and everything, when we go to the practical aspect of our content, you will notice that most of the things, in fact 80-90% of the things are completely automated. Like automatically VXLAN tunnels will form, automatically the Lisp configurations will be there, everything will be there automatically. You really don't need to know whole a lot of Lisp, VXLAN, or even the ISIS.
But at the time of troubleshooting, we need to know that. Or
in fact, again, a little bit of like knowledge is okay, which of course we will cover as a part of our content. We will go through some commands that are there in Lisp, that are there in the VXLAN from the troubleshooting point of view. But again, since we have a dedicated tool, assurance tab, we can do the troubleshooting from the DNA center itself. We do not need to know whole a lot of it actually. So, why, for example, Cisco recommends using ISIS? Because it's what they expect to see when you raise a tag case to them. They expect to see the ISIS running in the underlay because they have been trained on the ISIS. They have been trained to troubleshoot the things on the ISIS. They have been trained that, okay, if anyone is going to use the DNA center, they will use in the underlying infrastructure, they will use the ISIS. And that is one of the biggest reason why most of the companies are not going to the SDA. I personally know a few companies, a few candidates who work for a few companies. Cisco offered them free DNA center, like 2-3 DNA centers, free, completely free of cost. But they still did not go for the SDA solution. Why? Because of the same thing. They wanted that the infrastructure, they were running EIGRP in the underlay infrastructure, and they said like, okay, you should migrate from the EIGRP to the ISIS. Now migrating is a very long process. Also you in your company, people don't know ISIS that much. What if you run into some problems? Let's say DNA center is pushing all the configuration in an automated fashion, but still whenever it comes to troubleshooting, you need to do the troubleshooting all by yourself. So if let's say, for example, ISIS neighborship is not getting established between two devices, and your company, no one knows about the ISIS, then you need to open a tag case, then they will respond. So it is again going to be a hectic process. So a lot of companies, they do not right away migrate to the SDA solution, thinking about the same, that okay, they need to change the underlying configurations and everything, which is going to take a lot of time. And of course, if something goes wrong, then downtime will be there, and no one wants any downtime in their production environment. So migration is a very, very tricky step in case of like SDA. What people typically do, what they do, they deploy, for example, or they start by migrating a few devices, like a few devices they migrate, they put the users into those devices, and then they migrate the next devices, then they put the users into those devices, then they migrate the next devices. They do not just migrate like whole, like everything at the same time. More like some incremental updates migration is done in that situation. So like to create the underlay network, you can use any protocol, but Cisco recommends that you use ISIS, because it's what they expect to see while doing the troubleshooting or anything when we have raised any tag case with them. We can use EIGRP. We will use EIGRP. In our content, I will show you how when we talk about the LAN automation, I will show you how the DNS center is pushing the ISIS configuration in automated fashion. But once done, we will remove it and we will go for EIGRP. We can use OSPF. We can use any protocol, any IGP protocol. Just to give you the idea that ISIS is not actually mandatory to use in the underlying infrastructure in the DNS center. So we'll talk about like what services are dependent and those things. So to create the fabric, we'll require underlay, we require overlay. In underlay, typically it is expected to see ISIS. In the overlay, it is expected to see Lisp and VXLAN. And do not forget Cisco TrustSec. CTS, although it is going to be here, but Cisco TrustSec is also a protocol that is used in the overlay network to enforce the policies. So policy enforcement is done by Cisco TrustSec, CTS. No, Ravindra. LAN automation is to build the underlay network. Only one device you need to configure, and that device must be reachable with the the DNS center. And that device, from that device onwards, we can discover other devices if they are compatible, and then we can form like the necessary configurations on them. Traditional switches we cannot do. No. Only compatible switches. Only those switches can use this LAN automation process that are compatible with the DNS center solution, SDA solution basically. One more thing. It's not like traditional switches are not at all compatible. It's not like that. Like if we have a traditional switch, it's not like it is not at all compatible. We will not be able to take the benefits of the SDA, but we can still do monitoring and everything from that device. Even if we have a traditional switch that is not compatible with the SDA solution, not compatible basically means we cannot set the rules. We cannot use it. We cannot basically have the VXLAN and all those functionalities on the device.
We cannot manage centrally.
No. We can manage. That is the point. We can manage it centrally. We can get information from that device centrally, but we will not be able to push any SDA related configurations onto those devices, such as like VXLAN. So it's not like those traditional switches are not at all compatible with the DNA solution or with the SDA solution. But the point is that we at least will be able to see the in and outs of what interface is up, what is down, what is going on, what is receiving, and all that thing. We can do that level of monitoring on there. Basically, we can do everything except for the SDA onto that devices.
So fabric level encryption.
That is possible. We do have like we will have a few switches that will be configured in the same manner. So you will know like, okay, what things are compatible, what things are not compatible. And this right here at the very end, which we are not going to focus a lot, but this is also an essential part of our SDA solution. That our SDA solution can be also controlled via the entire DNS center functionalities can be controlled with the help of APIs. In fact, this is API right here. This that you are seeing here. So, for example, you go on this DNS center, like you can. This is the main dashboard. What happens actually when I click on this, when I click on this, when I click on this, What is happening in the background? That our browser is sending some request to the DNS center. DNS center is giving us the response, and that is being done with the help of some APIs. So either we can use the GUI, either we can use the graphical user interface to interact with the DNS center using the API, or if we have good enough knowledge, you can directly use those APIs in a third-party automation tool such as Postman. So, or we can create scripts like Python scripts we can create, and we can run those scripts from the automation tools, and those scripts, those automation tools are going to push the configuration to the push instructions to the DNS center, and DNS center is going to push those things towards the rest of the network. So you do not even need to go on all these live devices one by one. Even in the GUI, you can just create the scripts and do the things from there. And everything regarding the API related things is available in the dashboard as well. Everything you want to know about the APIs, right here. Here, platform. This platform tool that we have here, we have this thing called developer toolkit. Within this DNS center GUI itself, go to the platform, go to the developer toolkit, and right here we can expose, we can actually use variety of APIs. We can, let's say for example, you want to get the inventory information and you don't know what is the API call to get the inventory information. You don't need to go any, you can refer to the API documentation provided on the website. But even if you don't want to do that, you can check all those things right from the GUI itself. You can just go on here, you can just go to the API, and here it will list a lot of APIs, API like URLs, calls, and everything that you can directly use in your automation tool and make the API calls. So either you can refer to like the websites for the API interaction, for the call, like URLs, commands, and whatever you call, we call them URLs and all. Otherwise, you can just directly use this platform developer toolkit option provided within this DNS center itself, and we can actually know about the variety of things that we can do with the help of APIs. So this right here means that our DNS center has programmatic interface. It is a programmable infrastructure. That means we can have our variety of automation tools that can interact with our DNS center and push variety of informations onto the DNS center, and DNS center can take that information and push that information to the rest of the devices. These are the components of our SDA solution. So we need a controller, DNS center. We need a policy enforcement engine, ICE. We need fabric, underlay, overlay with the help of the protocol such as ISIS, Lisp, and VXLAN. And we can also use these third-party automation tools. We can expose variety of DNS center APIs to configure this DNS center, configure this SDA solution in a more like an automated fashion. That is automation. This is not automation. That is automation. This is like this. This is not automation. This right here, it's not like the automation. It is just GUI. From here we are doing the things. Automation basically means we are going to use some automation programs, tools, and then we are going to create the scripts. Those scripts will be pushed from those tools to the DNS center, and DNS is going to push the necessary configuration based on that onto all the devices. DevNet certification is specifically focused on this API interaction and everything. So at the very end, we will do that. At the very end, we will go through some generic, if some time will be left, then I will show you things on the Postman. If not, then I will directly show you on the browser itself. We can directly, expose the APIs with the help of the browser. So we don't need any automation tool, because if you use the automation tool, you need to set some environment variable. You need to, get the authentication tokens and everything. A process is there. So if some time is there, then I will definitely show you. But if not, then I will use because that thing is covered in the automation track. So otherwise I will show you like from here itself, how can we actually use variety of like APIs to expose variety of things on here. So that we will see at the very end. But from the solution point of view, these are the things that we will need in our SDA. Here, Same thing. This is how we are going to build our SDA network. So from the design point of view, we will require routers and switches. For the wireless, we will require AP and WLC. For authentication authorization, we will require Identity Services Engine. For the controller, we will require DNS Center. In fact, nowadays, we can have also like firewalls. We can also have certain firewalls controlled or managed by the DNS Center. Again, what level of functions we can control, that is going to vary. So when you integrate a firewall device onto here, then you will know. And then what protocols we require, we can use any IGP to build our underlying infrastructure. However, it is preferred to use ISIS, VXLAN for the data plane, Lisp as the control plane, and the Cisco TrustSec or CTS for the policy plane. We will talk about each and every protocol. We will talk about each and every component throughout the content. How we are going to build the network. This is the campus fabric. Here we have certain devices. From our traditional network point of view, these are the access layer devices, which have been aggregated at this layer called access layer, then the distribution layer, and then we have the core layer. Then we have campus edge and all those things. So from the architectural point of view, we don't need to change our underlying infrastructure. Let it remain as it is. Don't change your underlying infrastructure. Your underlying infrastructure or the underlay network will remain as it is. All that matters is the reachability. In fact, even if these are not SDA switches, no problems at all. This could be like, even if not Cisco vendor, it's okay, no problem. You will not be able to manage these devices from the DNS center if they are not Cisco devices, and you will not be able to, for example, like do SDA related configuration if they are not SDA compatible. Rest, like we have our campus fabric built, or campus fabric was already built. Now what we are going to do, we are going to set based on the position of the devices, we are going to set the roles on the devices. Basically, we are going to create the overlay network on the top of this underlay infrastructure.
So this topology, it's like access leaf, spine, border leaf, or
no, that we will not, we will not relate it from the DCACI point of view. We will relate it from the normal like access layer, distribution layer, and the core layer. The typical, the traditional network point of view. From there, like we are going to relate it. Right, because spine leaf is specifically for the data center, right? So we, from the campus network point of view, we have that 2-tier or 3-tier design. So we are going to relate it with that 2-tier access distribution core or 2-tier access and core distribution from that point of view.
That means in the distribution layer we can use any type of the switch, any vendor like
Yes,
Huawei.
Yeah. As long as they support routing.
Okay. Not L2 switch. L3 switch is required. Am I right?
No. Because when we move to the design part of our SDA training, we will notice that this all is going to be layer 3. We no longer are going to use like this. We will discuss why, but we are no longer going to go for this. We will go like complete layer 3. So these devices must be like routing capable.
Okay, thank you.
So the Cisco DNA only communicate with Cisco devices. So
yes, at least
not
at the
supported by
as per their
other
product documentation. Yes,
even if these devices support by netconf or
so again same thing. You might be able to discover those devices, but it will refer to as unsupported devices. You might get certain level of information from there, but not everything you will be able to manage about those other devices. So see, the point is that for the device discovery purpose, that DNS Center is going to use tools such as, for example, SSH, right? It is going to use tools such as protocols such as, for example, SNMP and netconf. So if these protocols are supported on the device, practically speaking, the DNS center can discover those devices. It can show those devices in the inventory. But the problem is that since DNA, all the devices that we have in our DNA, they required a specific hardware. Since that hardware might not be present on these devices, it will just show you unsupported devices.
I see.
So you will not be able to do a lot of things on there, but still, like some degree of like control you will have about those devices onto your DNS center. But to summarize, Cisco SDA is for Cisco devices. Okay. Now, when it comes to the wireless, we have a WLC. It is what we refer to as fabric enabled WLC. It's not a normal WLC. It is a fabric enabled WLC supported by the DNS center. AP, these APs are also supported by the DNS center. All the hardware must be supported by the DNS center. So these access points are managed by the wireless LAN controller. These access points are, we say that DNA compatible access point, and these are also DNA compatible wireless LAN controller. There is a dedicated series for the same. Yes.
WLC should be catalyst WLC or
catalyst. I will say C, yes.
Okay.
We will see that. However, we will see that when we go to the compatibility matrix, you will get the exact answer for the same. But short answer, yes. Then we have our DNS center eyes somewhere in the network. They don't need to be present in the campus network itself. They can be anywhere, such as, for example, data center, They can be anywhere. All that matters is the reachability. Reachability from these devices to the DNS center and the identity services engine. How are you going to make the reachability? With the help of like MPLS, with the help of like internet, DMVPN, whatever, it doesn't matter. How you are going to make the reachability is your problem. As long as the reachability is there, as long as the DNS center can reach to all these devices, it will be able to manage these devices from one centralized point and build the overlay network on the top of the underlay network. These are the benefits that we get. No such like guidelines for the same. If you're talking about like from the reachability point, from the reachability point of view, yes, there is some guideline. Yes, there is a guideline regarding latency. Actually, we will see that. That is part of our content. We will see like where should we place the WLC, where should we place the AP, the DNS center to the edge node. There is a latency consideration that you need to make sure of. We have that in a chart in our content. We will see that later on. So we get like a complete visibility in our network with the help of the SDA. We can enforce the policies based on the group rather than enforcing the policies based on IP addresses. That functionality we get in our SDA. Policies are going to be consistent through wired and wireless network. We don't need to configure two different set of policies. So that is all. These are a few advantages that we get for our software defined access or the SDA solution. DNS Center offers 4 major workflows: design, policy, provision, and assurance. 4 major workflows are there in our DNS Center. Design, where we design our network; policy, where we configure the policies for our network; provision, when we do the configurations, from where we can do the configurations of our devices; and assurance basically means like from where we can do the monitoring. Right, so DNS Center offers these 4 major things. It can sit inside and outside of the network. It doesn't need to be available in the campus network. As long as the reachability is there, everything is going to work fine. And then we have variety of devices such as switches, such as routers, such as some IoT network can be there, employees network can be there, wired can be there, wireless can be there. Users can roam from one point to other point without any problem. A lot of functionalities we will notice throughout the content that we get in our SDA solution. This is just again listing some benefits of our SDA. So Cisco SDA is an enterprise networking solution based on intent. Intent-based network views the network as a single system, and it translates and validates the business goals into the network and returns the actionable insights. So DNS Center can take, like for example, our intent-based network built with the help of the DNS Center can take a variety of inputs from the devices. It can also suggest the variety of actions based on the inputs that it has taken. It can use its artificial intelligence machine learning capability to give you better insights of your entire network, and based on that we can configure variety of policies. For example, it can tell you that a certain branch the YouTube utilization is going very high, so we can configure the policies to restrict the traffic of YouTube into that particular branch. Two major things will require for the DNS for the SD-Access. One is the campus fabric and the DNA center. In the campus fabric, we will have two things. One is going to be underlay and one is going to be overlay. Underlay is going to be underlying physical infrastructure responsible to provide the reachability between all the devices and the DNA center in your campus network. Traditional physical network connecting LAN devices such as routers, switches in the network is known as the underlay network. Underlay network is responsible to provide the underlying reachability in your network, and on the top of that underlay network we are going to build an overlay network with the help of our SDA solution. So an overlay network is referred to it is referred to as a fabric. Typically in terms of SDA, overlay means fabric. Fabric means overlay network. It is a logical topology that is built on the top of the physical underlay network. This overlay network will be built with the help of protocol Lisp, with the help of protocol VXLAN, and with the help of protocol called Cisco Trust. One by one, now we will talk about the use cases of this network. Here, like how the migration and everything will be done. We'll talk more about this like SDA solution tomorrow. So this is like the components that we are going to use in our SDA solution, the devices, the use cases. We have already talked about the use case. You can go through it, but we'll talk about that tomorrow. The use cases of the SDA, what benefits we get from the SDA, and how can we migrate from the traditional to the SDA. We'll talk about that, and then we will move to the technical terms in our SDA, which is like how can we build our SDA architecture. So for today, cover up to this point, cover everything up to this point. Tomorrow we'll talk about some more use cases of the SDA and how to build the SDA architecture.